Okay, we're going to start in just a moment. If you haven't already, please reach out and grab your handouts. There should be a test procedure for everybody and a checklist. That's our Appendix B assist sheet. A couple days ago, we sent out an email, hopefully to everybody that's online, so that there was a link to a folder so everybody can go in and get these handouts if you're online. We're going to try to put that link in the chat as well. So if anybody didn't get one, they can access them. But we'll start in just about 1 minute.
Yeah. All right, guys, welcome back to day 2. Just want a few little things. One, if everyone would sign in again, so I don't have to pay for your lunches today, that'd be lovely. And then everyone online to mute themselves, which I think everyone has. And then just cell phones. We'll have lunch served again today at noon.
Okay, good morning. I'm Aaron Davis. I work for the Scripps Institution of Oceanography. I'm an engineer that helps with their ship operations, and I help run the winch pool as well. So, first thing, we're going to talk about the Research Vessel Safety Standard Appendix B. What that is a 10-page document in the back of the Research Vessel Safety Standard. The point of this document is to improve the safety of personnel and gear used to deploy oceanographic instrumentation. It wasn't pulled out of thin air. It's based on federal laws that already apply to Subchapter U or inspected vessels. Those are vessels that are 300 gross tons or more. To give you an idea of how big that is, that's the Oceanus on the left. That was about 240 gross tons, I believe. And on the right, that's the research vessel New Horizon, or the former research vessel New Horizon. That was just about 300 gross tons. So anything about New Horizon or Oceanus and above. But Appendix B extends these regulations to all research vessels in the U.S. academic research fleet. So what is an overboard handling system? An overboard handling system is gear used to lower things below the surface of the water, gear used to drag or tow things in the water, and gear that includes a tension member paid out beneath the surface of the water, which becomes part of the line pull at the head sheave or winch drum. So that seems clear enough, but it's not. I get questions about if Appendix B applies to different equipment and different situations. So I put together some slides to try to clarify what is and is not an overboard handling system. So this is an example of a ship with an overboard handling system and includes all the components that are typically found on a research vessel. For this purpose, there's a winch, the red thingy, a tension member, the purple thingy, or the magenta, a frame or a boom, a head sheave or an overboarding sheave, and a thing we're trying to deploy in the ocean. So are the sheaves and the winch required for this to be called an overboard handling system? What do you guys think? No. If a tension member is attached to the frame and the thing, it would still be an overboard handling system. What if we took the frame away? What if it was just a thing attached to the vessel with a wire rope or a cable to it? Would that be a handling system? It would be difficult to deploy something in and out of the water, but if there was a tension member underwater transmitting tension from the thing to the boat, technically that would still be an overboard handling system of some kind. What about this? It's the same equipment, Now we're just dragging something behind the boat. It still has a winch, a frame, a sheave, and a tension member. It's being used to drag something in the water. The tension member is below the surface of the water, and the tension from the tension member is being transmitted to the rest of the gear. So this is also an overboard handling system. What about this one? Same system, same components, but is this an overboard handling system right now? I heard no. Why is that? Tension member is not beneath the surface of the water. So if you lower, say, a buoy into the water with your system, if at that instant or in that evolution, it's not an overboard handling system, and Appendix B won't apply. Same thing if you're dragging something behind the boat. If it's not under the water, the tension member is not under the water, Appendix B doesn't apply. What about that thing? It's a weird thing, right? Same system, same components, but some weird thing is being deployed. Some of it's under the water, or some of it's on the water, some is wrapped around the sheave, some's on the ship. Is the system attached to this thing an overboard handling system right now? Does Appendix B apply? There's no tension member below the surface of the water. So as weird as this thing is, there's pretty good examples of this thing out there. What do you think some of them might be? I'm not sure about mock nest. Usually there's a cable going under the water to the mock nest. But a mooring or a streamer, if the tension member that's part of the handling system is not underwater, Appendix B would not apply in those situations. Yep.
So you talked about a mooring. What if you're going to, like a shallow water mooring, anchor, you're doing anchor first. Tension member is not technically onto an anchor.
So the question was, a mooring has a cable in it, usually, and that's a tension member. We consider that a tension member, but it's not a tension member that's a component of the handling system. It's actually just one big long thing that we're deploying. It's the instrument. Here's a different one. Last one, this system's entirely different. It's a big purple robot arm of some sort. The arm has lowered a thing below the surface of the water. The arm itself is in the water. Is this an example of an overboard handling system? I see some slight yeses and slight nos. No, the tension member, the system does not have a tension member below the surface of the water. So it's not an example of an overboard handling system. So Appendix B would not apply if we had a big purple robot arm. Oops. So why all the focus on the tension member? Why is the underwater tension member so important? Let me answer that question by asking another one. What is the worst thing that can happen to an overboard handling system? Entanglement. That's what we call it when a tension member or the thing that we're deploying becomes tangled up in something underwater. So it's clear to everybody this is some sort of underwater monster that's been ensnared. A large moving ship has an enormous amount of momentum. No earthly force is going to abruptly stop it. If a large moving ship is suddenly tethered to something, things are going to break. It is safest and less costly if the tension member does the braking. For this reason, Appendix B contains rules to ensure overboard handling systems can be pulled on until the tension member breaks or until the tension member is let go of in some way or another. Yes, Rick? It is, but I think the idea is that the tension member is a rope or a cable or a wire rope. It's something that can trail behind the ship, get caught in the prop, wrap around the submarine. Am I right, Ted? But it's not likely to get tangled up in something underwater. It's not likely to be kilometers long. Okay, so let's look at what the rules are in Appendix B to protect us from entanglement. So, rules for overboard handling systems in Appendix B. We've said that Appendix B aims to improve the safety of personnel and gear used to deploy oceanographic instrumentation. The rules aim to do this by specifying how strong an overboard handling system has to be, by specifying tests and inspections we have to do to verify it's as strong as we think it is, by specifying markings we have to put on the system so everybody knows how strong it is, just by glancing at it hopefully, although that sometimes is difficult. That is, it's difficult to label equipment sometimes in a way that tells the whole story. By requiring us to train people to use the gear so they don't kill somebody or themselves with it, and by requiring us to document our efforts to comply with this regulation and show the documents to inspectors so they can verify we're doing all the things we're supposed to. So the first design rule has to do with the stress in our equipment. What do I mean by stress? Most of you probably already know this, but anyway, what a force is applied on a piece of metal, it experiences squishing or stretching inside. For example, if you put a metal beam on top of a couple little red sawhorses and push down in the middle of the beam, the inside of the top of the beam is going to get squished and the bottom will get stretched. The intensity of the squish and stretch is what we call stress. Appendix B assumes overboard handling systems are made of metal. Most metals have what's called a yield point, which is an amount of stress. If a force is applied to a piece of metal and the stress inside is small, the metal may bend, but it will snap back into its original shape when the force is removed. If a force is applied to a piece of metal and the stress inside it is very large, the metal will bend when the force is applied and will remain bent when the force is removed. It will be ruined. We call that amount of stress the yield point of the metal. Which brings us to the first design rule in Appendix B, the maximum stress we can have in components of an overboard handling system. We don't want them to get ruined, so Appendix B says this: whatever the yield point of your component is, divide that by 1.5, and that's the maximum stress you can have in it. Most folks don't need to worry about this. It's mostly a rule for engineers that are designing equipment. The next design rule has to do with the strength of overboard handling systems, how much the gear can be pulled on without ruining it. On inspected vessels, that is the big ones, 300 gross tons or more, overboard handling gear must be designed to be pulled on until its tension member breaks. That way, if the ship is cruising along and the tension member gets tangled up in something, the tension member will break and nothing else will be damaged. However, in Appendix B, it's worded a little bit differently. It says, for inspected vessels, system components shall be designed as a minimum, I think that's actually at a minimum, to withstand and operate in excess of the nominal breaking load of the strongest tension member used. So what is the nominal breaking load of a tension member? It's the advertised strength of that tension member, what the manufacturer says it's supposed to be able to do. There's a lot of confusion about what withstand and operate means, especially for manufacturers of equipment. First, it means that the system must be entirely undamaged and operate after being pulled on until its tension member breaks. It also means that while it's being pulled on, the overboard handling system must hold fast. Winch drums cannot turn, hydraulic cylinders must hold their position. It does not mean that overboard handling systems must be able to lift or pull hard enough to break their tension members. Appendix B has different rules about the required strength of overboard handling systems on uninspected vessels. That's what we call our smaller ships. On these ships, the overboard handling system does not have to withstand the breaking strength of their tension members if the system includes one of these three things: a weak link, a torque limiter, or an auto render system. These things act to limit the tension in the tension member to an amount the overboard handling system can withstand. These are the things that let go of the tension member, as it were, if the tension's too high. So what are these things? I'm sure most of you are familiar with weak links. Imagine a chain with a bunch of strong links and a baby little one. The chain will break when the weak link breaks. Since it's most likely is the thing at the end of the tension member, the instrument, or the dredge, for example, is what will get tangled up in something underwater. We often use weak links to join the instrument to the tension member. A weak link has to be something specifically designed for the task, and it must break at a specific tension. A torque limiter. Our overboard handling systems generally include a winch. A torque limiter is a clutch, a relief valve, or some other apparatus that allows the winch drum to slip a bit to turn if the winch is being pulled on too hard. The torque limiter must activate at a specific torque, that is, when the drum is being twisted at a specific amount. When the pull on the drum lessens, the winch must be able to operate normally again. It must reset, as it were. An auto render system is just another kind of torque limiter, except that a computer carries out the process instead of a mechanical apparatus. The computer senses the amount of pull on the tension member. If it's too great, the computer causes the winch to pay out or unspool the tension member until the amount of pull is okay again, or the tension is okay again. If the overboard handling system on an uninspected vessel does not feature one of these things, it also must withstand and operate in excess of the breaking strength of the tension member. The last design rule when it comes to strength has to do with the direction an overboard handling system or a component of one is designed to be pulled on. Because it features a tension member, it can be pulled on from practically in any direction. That statement is a reminder of this. This statement is a reminder of that. It's to remind people designing these systems to consider all the various things their customers will be doing with it. Frankly, they often don't know. So if you're buying an overboard handling system or a component of one, make sure you elaborate on the various things you aim to do with it and how that will affect the direction they'll be pulled on. Keep this in mind when you're evaluating a piece of used gear. Make sure it's okay to pull on it the way you aim to pull on it as it's being used at sea. There's also some design rules that don't have anything to do with the strength of our overboard handling system. There's some features that they must see. Keep these features in mind whenever you're evaluating your existing system, retrofitting it, or purchasing a new one. The title of this section is a bit confusing because it's called Recommended Design Features, but it's not a recommendation. They're all mandatory except for the last one, the Maximum Capability Document. So guards, they must be installed to prevent personnel from accessing pinch points or rotating machinery. Signaling devices must be installed to warn personnel machinery is going to start. They're very important when machinery is operated automatically or remotely. Emergency stops, they must be installed at each operating station and local to the equipment. Electrical safeguards must be in place to accommodate lockout or tagout procedures. There must be fuses or circuit breakers preventing electrical overload as well. Manual operating devices. This has to do with the system's controls. The controls, the control levers and buttons and whatnot. They must be of the dead person style, like spring-centered control levers. The term dead person means if the operator were to fall over dead and presumably let go of the controls in the process, the controls will automatically return to a neutral, non-operating state. Maximum capability documents. The document that defines the safe working tension of a piece of equipment, among other things. I'm going to elaborate on what they are a little bit later in the presentation. Any questions thus far? Okay. So installation. Now we're going to move on to the section of Appendix B that has to do with testing and inspection. How we verify our overboard handling system or component is as strong as we think it is. The section on installation tells us how to inspect our gear when it's first installed on a vessel. We have to be sure that the I put that in there. It's supposed to be the overboard handling gear is installed in accordance with the manufacturer's instructions or requirements. Suitable safety guards are in place. Operating limitations are posted appropriately. This is generally as simple as stenciling the gear with a safe working tension and making sure it's visible at the operating station. Of course, post anything else that is important, such as never push the red button or the blue button simultaneously. Some systems have weird interactions that aren't desirable. The trim and stability limitations of the vessels aren't exceeded. Obviously, this is something that needs to be discussed way before the installation. Okay. Testing. Now we're going to talk about testing. When we talk about testing, we're mainly talking about load testing, hanging a weight on our overboard handling system or pulling on it in some other way to make sure that it's as strong as we think it is. Of all the things we have to do to comply with Appendix B, testing can be the most difficult. That's because Appendix B requires us to test our overboard handling systems as they're used at sea. At sea, this is easy. It's easy to simulate pulling out a huge core sample out of the bottom of the ocean when you're pulling out a huge core sample from the bottom of the ocean. But we do these tests in port, which causes a lot of obvious and not so obvious problems. I'm going to run through all my slides about testing, and afterwards, I have a testing procedure that I put together for one of our handling systems. I think it'll be instrumental to discuss the various things, the various steps involved, because there's a story behind each one, and it kind of brings to light some of the common problems we have when we do testing in port. So, we do load tests to make sure the engineers that designed the overboard handling gear didn't screw it up. Make sure the fabricators that built it didn't screw it up. The people that are installing it didn't screw up. And to be sure the ocean environment hasn't eaten it up yet. We test every component of an overboard handling system in some way or another. Deck hardware. It's unique because we don't have to load test them. We test them in another way, and I'll elaborate on that in a minute. Every other component has to be load tested. It can be load tested as an entire system installed on a vessel. This is the most desirable way to do it, in my opinion. But it can be load tested a piece at a time if that's more convenient, or if you just have a piece, like a block, you can test that in the laboratory or at a rigging shop if you want. It doesn't matter so long as every component is tested in the way that it's used at sea. We test our overboard handling systems and components when they're brand new, then we test them every 5 years after that. Initial testing and assessment. This is what we do when an overboard handling system is new. The owner is responsible for the testing. If the gear will be part of an inspected vessel, one of the big ones, invite the Coast Guard to observe the test. They're going to want to do that, and you don't want to do it twice. Before conducting the test, we look at the gear to ask ourselves, does this thing look like it'll do what we want to do? Does it look like it's up to the task? If it doesn't, it probably isn't. If it does, we test it by putting a large load on it, generally by hanging a test weight from it or something like a big, huge bag of water. We do this to every component that's redundant, one piece at a time or as a whole. Does everybody know what the safe working tension is of the system? It's the largest tension that could be on the system during normal operation. Generally, it's the safe working tension of the tension member, the weak link in the system, hopefully the weak link in the system. It's a number that's generally specified by the manufacturer. We generally test each component to 125% of its safe working tension. So it's a good idea to ask the manufacturer if this is okay. Sometimes they don't foresee this happening and they get kind of worried. Again, this is something that if you're buying a piece of gear, you should specify ahead of time so they know what you're going to do with it. After we carry out the test, we inspect each component to make sure it looks all right. Periodic testing, that's the testing we do after it's new. We do it every 5 years, and we test each component as it's used at sea to 125% of its safe working tension. Deck hardware is unique. Deck hardware is shackles, links, swivels, bolts, all that other stuff. We do not load test them. They're load tested in the factory. What we do is we inspect them for damage. We ensure the load rating or grade is still visible. Don't purchase things that don't have these markings, or there's no way to inspect them. And if they failed, if they seem obviously damaged, worn out, or you can't read the markings anymore, they fail. Again, we do this when they're new and every year, 5 years after that. Deck sockets. These are the threaded holes in the deck of a ship. We use to bolt things to it. This one shows, the one shown to the left, I guess that's my left, it's not your left, to the right, has a plug screwed in it to keep the water out. Ships may have thousands of them in their working decks and other places. When overboard handling gear is bolted to these sockets, they also become part of the overboard handling gear, and therefore Appendix B applies to them. They have a certain strength, they have to be of a certain strength, and you have to test them and so on. However, if overboard handling gear isn't bolted to them or won't be bolted to them, you do not need to test them in the way that Appendix B tells you to. Keep that in mind. Testing every socket on a ship is a huge undertaking and it's generally unnecessary. And in my view, the most efficient way to test deck sockets, although admittedly it may not be the most practical, is to bolt the overboard handling system to them and test them, the whole system at the same time. Yep.
I don't know if you're aware, but the department has purchased a system.
Okay, so there was a comment, and that was that Hui has purchased a deck socket tester. Is that the Einhorn tester?
Yes.
Okay, that's available to the fleet to test their deck sockets. That allows one to test them one at a time if you want to. Yes, ma'am?
Yeah, they, Mike Einhorn made this, so from Einhorn Engineering. And so University of Alaska also has one, and it's housed right now at University of Washington. So there's 2 in the fleet. So if anybody needs those, they can be sent around.
Okay. Okay, so that's everything I have to share about testing, except this procedure. If you can pull it out, take a look. Yes, sir.
Back to the shackles and inspect those visually. How's the stainless thing? And look at the stainless steel shackles and such, and you won't see that there's a problem going on inside the unit. Is there any recommendations you have for doing that, or you just replace them periodically?
So the whole comment was that stainless steel deck hardware doesn't necessarily have any, you can't necessarily see the damage inside of them, corrosion, et cetera, is that right?
Yeah, they sort of rot from the inside and it looks fine on the outside, as opposed to, non-stainless, which, you can clearly see if it's deteriorating or not.
Well, my guidance would be probably don't use that stuff then. But you're right. If that's an issue, then the simple visual inspection probably isn't going to cut it.
Thank you.
Rick?
Follow up on hardware.
Oh, hold on, Rick. Let's get the mic involved.
So my comment is about hardware.
it's not uncommon at the conclusion of a mooring cruise where similar types of hardware that you show have been at sea for a year, 2 years, subject to a lot of fatigue. Is there a concern about the use of that hardware, which can look pristine, but it has a lot of fatigue cycles on it?
Mm.
So I'm just wondering if there's any guidance or just to raise that point, because we did find, for example, that a pair ring placed on a mooring was a source of fatigue failure, and these parts do deteriorate.
Hmm. There is no official guidance about that, but that is a problem. I think the assumption would be that we're going to use the assumption, you know what they say about assumptions, we're going to use our deck hardware for our overboard handling systems exclusively. But you're right, even the stuff used on board the ship, I guess the assumption is that if it's super old, it's going to be visibly messed up. But you're right, the situation that you bring up, that things are just fatigued, they might have been used for another purpose or something and then ended up on the ship. Our inspection would not catch that. So maybe that's something we should consider in the future. Any other questions before we proceed? So as I said before, I wanted to go over this test procedure, not because it's necessarily an awesome test procedure or anything. It's just there's a story in it. A story of tears and frustration. And I'm just going to go over it step by step. People can ask questions or comments. I'll tell the story behind most of the things in here. And like I said, if you haven't been involved in making a test procedure or testing this equipment, maybe it'll kind of enlighten you as to what this might involve. So, in this test procedure, number 1, UNOL's RVSS Appendix B requires OHS to be tested to 125% of their SWT every 5 years. I put that in there because everybody kept asking me, why are we doing this?
Also, if it changes to the structure, even after the change.
Right. If there's a change to the structure, we need to test after that as well. Number 2, this procedure assumes the nominal braking length. Sorry, there are errors in this. The nominal braking tension of the system's 322-inch diameter cable is 10,000 pounds. The safety factor used when the cable is 2.5. The cable's safe working tension is 4,000 pounds, and the minimum required test load is 125% of the safe working tension, which is 5,000 pounds. This answers the question I kept getting: where did this test load come from? And it reminds me of that as well, so I don't have to look it up. A lot of this stuff is just I got tired of looking it up, so I put it in the procedure. The next one answers the question, is this okay? Is the equipment actually going to withstand all this? In this procedure, the test load is 10,000 pounds. Let me back up. The required test load is only 5,000 pounds, 125% of the safe working tension. But in this case, the vessel master and some others decided they wanted to test it to a far larger load because the equipment was built for a far larger load tension. That presented problems, but we got it figured out. So the procedure, the test load is 10,000 pounds, which is less than the safe working tension of the Allied CTT-11B. That is the robot arm thing that's part of the system. The Markey Cast 6 125 winch, and the Smithburger 322 guide sheave. So that's just saying that all this equipment can actually withstand, and it's less than the safety working tension of all the equipment. And I don't have to look it up anymore, it's in the procedure. Step 4, verify that the dynamometer that will be used is properly calibrated. Step 5, verify the winch's tension member meter is properly calibrated. Number 6, disable the winch's render and recover function. That's important. And it might be wise before you do this the first time if you're to ask the manufacturer, is there a hidden render function? Is there some maximum tension at which the winch is going to pay out for no apparent reason? This system did have a render recover switch that we turned off or put in the right position. It had a hidden limit as well that was set to 10,000 pounds. That one had to log into the system and change before you did the test procedure. We found this out by filling up the water bag. When we got to about 10,000 pounds, the winch slowly paid out the cable and lowered the water bag onto the valve that lets the water out. So that was lame. Number 7, remove the termination from the CTD cable if required to completely haul it in. Number 8, haul in the CTD cable completely. Number 9, reeve a length of 3/8 diameter Samson M steel blue line with a minimum spliced breaking strength of 17,600 pounds through the overboard handling system with a spliced eye on its working end. This is going to be the test line. So if we had went with the test load of 5,000 pounds, we could have just used the CTD cable itself for our test line, and it wouldn't have harmed it. The safe working tension is 5,000 pounds for this line. And we've tested the cable with the termination on it, verifying that it actually holds the whole breaking strength of the cable for the one that we were using. This is something to consider as you design your own test procedure. Oftentimes these terminations can't hold the whole safe working tension or the test load. So because we use such a big test load, 10,000 pounds, we couldn't use the CTD cable anymore for our test line. So then what do? What we did is we got this AM steel blue line. Well, let's proceed. It says what we do. Lash the AM steel blue test line to the bitter end of the CTD cable. Haul the test line in until there's 10 or more wraps on the winch drum. So that makes the top layer of the winch drum kind of like a capstan. It holds the test line just fine. You just lash the test line to the cable. We found this works just great on a CTD cable that's wound real nicely. The CTD cable lays pretty flat and winds pretty tight. We found this does not work on 3x19 wire so hot. It does not wind very tightly. We did the same procedure on top of a winch on the Sproul, which only had a few thousand pounds. The winch itself only pulls a few thousand pounds. The top layer was pretty loose. And when we filled the water bag, the line dove into the layers of the rope and cut the test line. So from that point forward, our procedure probably for this one should be changed to put some lagging on top of the top layer of cable. We haven't had that problem with the CTD winches, but we do that for all the 3x19 direct pull winches. We wrap reinforced rubber or something to that effect around the winch, the top layer a couple times before we put the test line on it, and that keeps it from chafing, the test line from chafing, and it keeps the line from diving down into the layers of the wire rope and cutting it. So attach the dynamometer to the spliced eye of the test line. Number 13, attach the water bag to the dynamometer. 14, place the side handling unit in the cast and towing position. And there's a little diagram on the opposite side that shows the test and towing position. And this particular piece of equipment, there's a jib boom that comes out. We're not supposed to put a great load on the system when that jib boom's extended. Place the side handling unit in the cast and towing position. Pay out the line as required to keep the dynamometer well below the handling unit. We don't want to two-block it. Ensure the jib is completely retracted and within the limits showed in Figure 1 on the following page. Ensure it remains that way throughout the test. Ensure the water bag is in the proper position for the test, i.e. clear of the side handling unit, the vessel, and not above anything that might be damaged if the OHS or bag should fail. Slowly fill the water bag until the dynamometer indicates 10,000 pounds. Check for agreement between the dynamometer and the winch's tension meter as the bag is filling. If there's a huge, if you calibrated both, if both are supposedly calibrated and there's a huge disagreement, I'd stop and figure out what's going on so you don't overload something. Wait 5 or more minutes. Inspect the systems for signs of failure while you wait. Release the water from the water bag. Remove the test line from the system. Put the winch's render and recover function in the same state it was before the test was conducted. Let the vessel master and the winch and wire engineer, that's me, know when the test is complete so they can make note of it in the appropriate vessel logs, NS5, and in the UNOLS wire pool database. Obviously, in your organization, different people might need to know. Lastly, give the test line to me, who will inspect it, keep track of the number of tests it's used for, have it tested and or discard it. So in this case, and if you should use a synthetic tension member as your test line, we were loading the synthetic tension member to a much higher degree than would be recommended by the manufacturer. We weren't sure how many times we could do this. So what we've been doing is we'll do a test. We use the test line, document how much load was on it, take a sample after the test is conducted, send it to Rick for testing, and keep an eye on it to see how many tests we can do before it starts, showing signs of weakness or failure. Anybody have any question on testing? Yes, sir.
Quick question on 17.
No, hold on a second.
Just had a question in relation to the number 17 and what we spoke about yesterday about calibrating some of the sensors every 6 months. Would you consider, so if you had this set up where you had your dynamometer in line with your other sensors that are measuring the tension, and you compare those during one of these tests, would you consider that a verification of your calibration and that you could maybe forego doing actual calibration on your system because you're kind of testing it out empirically?
Well, this is how we do calibration. We load it. We load the system preferably to something around the safe working tension, and then verify that there's agreement between a calibrated meter and your ship's equipment. A little note on that is that a lot of these load cells we use on the ship, they're not linear. That is, an amount of load is not linear to, the curve looks kind of like this. So if you calibrated it to low a load, it might not be in the linear portion of the load cell's function, if that makes any sense. And I need to draw this. At any rate, you want to calibrate it to a tension that's somewhere around the safe working tension to make sure it's accurate at the higher end of what you're going to be using at, because that's where it's important. Does that answer your question? Yeah, okay.
So I just have a question. If you're testing to 125% of the nominal braking load, but you've sent your wire to Rick and he's broken it, and it's breaking at 12.5 instead of 10 or a higher number, does that change your requirements for testing to 125% of the actual brake load now that you know it brakes higher?
No.
Okay, you're just going with the nominal.
Yeah, the safe working tension is going to be the lesser of the test brake load and the manufacturer's nominal braking strength. If the tested braking load starts creeping below the nominal braking strength, then we're probably going to cut back or something. But if it tests stronger, we don't make the safe working tension of the tension member any bigger. It always just remains the nominal or lower.
As we saw yesterday, the tested braking strength can often be 20 to 30%, and I've seen numbers from the documents, up to past 40%. And I think one of the reasons wasn't in the background, but maybe that 1.5 that Aaron mentioned is kind of balancing that out. So if something's going to break at 40% above, you're getting very close to that 1.5. So there isn't much of a gap in there. So prior discussions, we looked at, should it be changed, but the rules are NBL, not nominal breaking strength. Question for Aaron. The initial testing requires exercising the equipment at that load. You're doing a static test here. Is there something I'm missing in not repeating the test as if it would be exercising?
Moving it?
Moving it. Particularly, I look at the A-frame example, is you put the weight out, or weight in, and you move it. If you did it static, which is kind of the old way of doing it, it doesn't represent the strength of the A-frame. And in the case of the Savannah, when they first tested it at acceptance, it was tested under load, a static load, over the stern, so I understand. I wasn't there. When Appendix B came in and they looked at, we got to test it and exercise it. So I put the load on and then exercised it, luffed it in, out. The worst case condition turns out to be probably the in position, but we went down to inspect it. The top of the rams, the welds there, had cracked. We observed it. We worked with them. They redesigned those weld systems and then went back and retested. And when I go on board, I look to see if it's been exercised as it goes through a test procedure as opposed to a static load. And so I'm looking at this and saying, you're not doing what I would think you would do to exercise it. Is there something I'm missing?
Yeah. If we were to test the whole system to 125% of the safe working tension, generally speaking, most systems won't move with that tension on it. That's not to say that it wouldn't be a good idea to test the A-frames and whatnot when they're luffing. As soon as you said that, I went, oh yeah, every time we get inspected, you say you're not testing, you don't have the luffing load on the maximum capability document, and you didn't test it in luffing either. I'm not entirely sure that Appendix B requires that, but that's certainly something that the safety committee could discuss and look into what's a good idea for that. Testing the A-frames in luffing is can be eerie. I mean, honestly, the safe working load of a lot of the A-frames is quite a bit less, when we're luffing than it is when we're deploying something, station keeping or something. So maybe we can use 125% of that luffing load or something. But then we don't typically, when we're moving, we don't typically want to put more than 80% of the most we should put on there anyway. So that's a complicated question. I think we should think about that. Yeah.
Sounds good. Some of the ships have a dynamic and a
Right.
static load limit.
Right. Is there another question? Yes.
There you go. So the point I want to make about luffing is we should really only be luffing gear when the packages are coming back on board. And if Appendix B only applies to the tension members in the water, then there should be no need to test luffing, unless you're trying to luff with the package in the water, which doesn't make a lot of sense to me.
No, yeah, you're right. Yes, Rick.
Had you conducted the test as detailed in line item 2 here, and you're operating the designated factor of safety of 2.5, in this particular case, 322 can be operated down to a factor of safety of 2. So if you tested it at 2.5, and then scientist A comes along and says, I've got this huge CTD package, I want to put it on, we're gonna need to operate at a factor of safety of 2. Does that mean you need to repeat the test with a factor of safety 2?
Yeah,
So wouldn't it be best to, I mean, I understand what you're planning to do, but if it's a 3x19 wire rope where you can test it down to a factor, you can use it down to a factor of safety of 1.5, maybe the test should be to that. And
well, in this case, the reason why the safety factor for these systems is higher than usual is because there's a turning sheave involved. There's a sheave on the winch's level wind, and then there's a turning sheave, and then it goes over to the handling apparatus. And the groove on that turning sheave is not tight fitting with the cable. So we're not using a safety factor of 2.
So you would, in that
We would tell
system,
them
you would never use it below 2.5?
tough, yeah.
That's what, okay, got it.
Yeah. Any more questions? We're zipping right through this. Where are we? So that brings us to labeling. After an overboard handling system or component is tested, it must be labeled. With the exception of deck hardware, it has to be labeled with a test date and a safe working tension. Labeling can be done at the system level or component level, whichever is convenient. A diagram showing the applicable tension member angles should be included whenever it's possible. It's often not possible. When the gear is only pulled on in 1 or 2 different ways, it's possible. If it's more complex than that, it may be difficult to make a diagram that clearly communicates the gear's limits. In that case, just say, see the MCD, put something up there, and see the MCD or some other note saying that it might vary so people know. We don't label deck hardware with a safe working tension. If it passes inspection, a piece of deck hardware is already marked in a way that indicates its strength, but it does tend to be marked, it does need to be marked in a way that indicates that it has been inspected in the last 5 years. In my view, color coding is the easiest way to do that. And when we get into the section about record keeping, you'll understand why. For example, if all the deck hardware was painted, say, pink after the last inspection, and a piece of deck hardware pops up that isn't pink, it's clear it wasn't inspected along with the rest of the gear. It can be set aside until it's inspected the proper way. Logs. As I said before, we test our overboard handling systems and their components to make sure that they're as strong as we think they are. We need to document or log these tests and other important events so we can convince other people, like inspectors, that we've done what's necessary to ensure everything is as strong as we think it is. We need to log the date when the last test was done so we know when to do it next, and inspectors know that we've done it recently enough. And other people on the deck. Doesn't make you feel good if you see an inspection date that's like 10 years ago. We need to include the name of the person in the logs. We need to include the name of the person that did the test and the name of the test method. We need to log anything that happens that might impact the strength of the gear in one way or the other. If there was an accident, for example, if we did a repair on the equipment, it needs to be tested again, and that needs to be logged. Inspections that we did, and so on. The logs must be sufficient to determine the test date of every component, hence the color coding. We can just put in the log. On July 5th, Aaron Davis inspected all the standard deck hardware on the ship using the inspection method, Rev B. The hardware that passed was painted pink. Then every component is covered. Otherwise, don't ask me how you're going to do that. If you have any ideas, I'm open for, I'd love to hear them though. Training. So we focused a lot of effort on ensuring the overboard handling gear is strong enough. For safety reasons, all these efforts are meaningless if we allow somebody that has no idea what they're doing to operate it. For this reason, if an overboard handling system or a component of one requires an operator, a formal training program must be developed for it. And by formal, that means written. Personnel must successfully complete the program before operating it. The training program must cover each operating station if there's more than one. It must be hands-on whenever possible. It must require the operator to demonstrate proper operation. It must require the operator to demonstrate knowledge of safety procedures, the operating manual if there is one, and monitoring guidelines. That is, if it has gauges, meters, and so forth, the operator should know what's okay and what is not. Now we're going to talk about maximum capability documents, and that was mentioned in the design features section. I get a lot of questions about maximum capability documents, so I'm going to elaborate on them a bit, and we're going to take a look at one. In the past, they were not optional, and there was a long list of rules about what they must contain, but that's not the case anymore. At a minimum, a maximum capability document defines the safe working tension of an overboard handling system or a component. That is the greatest line tension that we placed on it. I should have silenced the mic for that. That is the greatest line tension that can be placed on it under normal circumstances. The design line tension is what we call the greatest line tension an overboard handling system or a component can withstand. If we pull on it any harder than that, then the maximum stress we talked about earlier will be exceeded. If the design line tension is known, it's best to put it in the MCD as well, but that's not a requirement. Not that the MCD itself is a requirement. If the overboard handling system or component is going to be used on an inspected vessel, the design line tension tells us how strong the tension member can be. So that's important to know. It can't be any stronger than the design line tension, or the system will be damaged if entanglement occurs. If the overboard handling system will be used on an uninspected vessel, the design line tension in our MCD would tell us when our tension mitigation device has to activate so the system isn't damaged if entanglement occurs. Reaction forces, also nice to have on an MCD. These are the forces that the overboard handling system or component will place on the ship itself. Or, hold on a second. Or reaction forces are the forces that one component of an overboard handling system will place on another component. If these are known and in the MCD, the information can be used to determine, say, which bolts to use when bolting one thing to another, which shackle to use when hanging a block from an A-frame, things of that nature. So here's an example of what an MCD looks like. It can look like just about anything. Again, the minimum requirement is it has to have the safe working tension in it. Otherwise, they don't even call it an MCD if it doesn't even have that. And tension is a vector. It has magnitude and direction. This has a nice pointer. Nice little vectors there showing straight down, which is important in this case. Also not required, but a good idea. There's a diagram of the block. The diagram shows the direction of the forces, which is important because the strength of a piece of overboard handling gear often depends on the direction the line tension is being placed on it. In this case, the diagram shows the line on the block is pulling straight down. This is the worst case scenario, so we know the safe working tension applies no matter what angle the line is on the block. So anyway, there's one example. This one was made by Smith Burger Marine. They make blocks and other things. This is about as simple as an MCD gets. At the same time, there's a lot of other information that's nice to have, but it's not necessary for a maximum capability document. If you're making one, just put the minimum requirements in there, and then anything else that is handy for you to know. Okay, overboard handling System Operators Manuals. These are mandatory. So we've gone to great lengths to ensure our overboard handling system is strong enough. We've trained its operators so they don't kill somebody with it. In the process of doing all this, if we've kept good records, we've amassed a lot of information. Inspectors and other people sometimes want access to it. The vessel master might wish to see it to verify the gear is strong enough and properly taken care of. The gear might be loaned to somebody. The person might want to see how heavy the gear is, how much space it takes up, how to maintain it. A lot of this information is very important if you have a portable piece of gear or a portable system. If it's a fixed system, then a lot of this information, though it's still required, isn't a whole lot of use. So the requirement contents of an overboard handling system operator's manual are: where each major piece of wet weight handling gear, I didn't stick that in there, let's see, sorry, overboard handling system, where each major piece of an overboard handling system is located on a vessel, how it's oriented with respect to other components, how the tension member enters and leaves the components, the angles, if they're important, the weight of the major components. The captain might need to know this if it's portable stuff. System particulars, important information that's not in the manufacturer's manuals, like turn this thing on instead of that, or before that. They have to have procedural safety requirements in them. And that's any safety procedures that are in the manufacturer's manuals or that you come up with yourselves that you feel are important. They should contain a list of all the relevant manuals and data sheets you have for the gear. And of course, it has to include how to maintain the gear. Again, a lot of this is important if you have a whole portable system. You can make this manual the old-fashioned way by getting a binder and some dividers and sticking all the relevant documents in the binder. But it's hard to share with people at remote locations this information if you do it that way. I make mine using Adobe Acrobat Pro. I just use Word to come up with the title sheets, the table of contents, make little cover sheets for each piece of information, and then turn that into a PDF. And then all my loose documents or other things, I just scan them and turn them into PDFs, or they're already in PDF format. And I just stick them all together with Adobe Acrobat Pro. That's how I do it. So I didn't print out any examples to hand out because these documents can be pretty gigantic. I mean, the one I made for most recently is like 60 pages long. But I did upload an example into the shared folder so that folks can take a look at what they look like. You can also email me. I can send you that example or a link on where to get that. I'm also available to help you make these documents. Any questions about this document? Yes, sir. Let me get you a mic.
In Aaron's developing of these, I asked him if he would do one more thing beyond what's required, and that was to make a introductory statement of the capability of the OHS system. In these documents, unless it's embedded, it doesn't tell you what the capability is. You might be able to find it in different places. So I asked him if he would do kind of an executive statement at the beginning, say these are the overall this is the overall capability under these conditions for this system. And I appreciate him doing that. And I suggest as you do it, you might consider that.
That's a good point. In the current version of Appendix B, there is no requirement to have the maximum capability of the system in the overboard handling system operator's manual. But if you know it, it's very handy. It's very handy. These can be handy documents to have. If you stick all the information you know about the equipment into one place and then manage that document, it's really good pass down because you know, crew members change, port engineers change, et cetera, and that knowledge is sometimes lost on somebody's laptop. So if you do know the information and you can put it in there, it's a good idea to do that. See?
Aaron, do you consider these documents part of your safety management system?
That is an excellent question. I have made these documents, and I have distributed these documents, and yet people are constantly asking me questions that are in the documents, and it becomes clear to me that they've never seen them at all, and there's no revision management, so somebody might have gotten one, and then it's an old one. So that's coming in our organization. That's coming soon. We're going to have a discussion about, and my boss is probably listening to this and saying, what? But this is an idea that's been in my head. This really does need to be part of the safety management manual so that we can have revision control, and so everybody actually reviews the documents and know what they contain.
Thank you.
But that's not a requirement in Appendix B.
This goes back to the maximum capability documents. I know that you showed kind of a very like simple Smith-Berger block, but do you have examples of other MCDs for, you know, bigger pieces of equipment like A-frames, FLARs, et cetera, that you could share?
I do.
Okay.
I do. We have MCDs for, I'm looking, thinking, we have MCDs for all of our handling systems.
Yeah, because I know that you said here's the minimum of what's like required, but like
Right.
what makes a good MCD if you're...
What makes a good MCD?
Yeah.
Completeness. The Glosson Associates, when you have a whole handling system, including a frame or a boom or something like that, it gets really complicated because what sort of operation you're doing and what angles are on the wire rope make all the difference in the world. So a thorough maximum capability document for a whole system is often very lengthy. But the Glosson Associates do a pretty good job of making them. They have, for example, in the MCD we have for the A-frames, they have a picture, a diagram of a system where there's portable winches on the back deck, or it's coming from, you know, one location or the other part of the fixed gear, and there's a maximum capability for that scenario. And there's just page upon page of all this, which just gets pretty complicated. So they break it down in a table in the front of the report for people that don't want to dive into all that or can't understand all that. And they have it broken down into every single scenario, if you really want to dive down into it in the table, and they have it broken down to, is it towing, or is it from the back of the deck, the working deck, or is it using the trawl winch? Just simplified versions. But yeah, I do have examples of those that I could share. You guys can just give me an email or something, and I could stick them in the shared folder along with everything else if you'd like. Any more questions? Okay. So it is very difficult to remember every little thing that must be done to comply with Appendix B. And fortunately, you don't have to. In the folder of examples I shared, and here in the class, in front of you hopefully, is an Appendix B assist sheet. It's a spreadsheet with 2 tabs, one for components and one for overboard handling systems, the whole system. If you want to see if you're complying with Appendix B, you fill out these sheets. If you only own a component, like a block, you only have to fill out the component spreadsheet to see if you comply. If you own an overboard handling system, you can fill out a component sheet for each of its components, then use them to fill out the sheet for the whole system, if that makes sense to you. Or you can just fill out the sheet for the whole system if you prefer. As long as the system level sheet shows that you comply, you're good to go. If one of the line items in the sheet doesn't seem like it applies, it probably doesn't. You don't need an operator's training program for a shackle, for example. Nobody operates that. You can put NA in that box. If there's a line that pertains to inspected vessels, but yours isn't an inspected vessel, you put NA in that box, and so on. And if you have any questions, you can feel free to email me. Does this apply in my specific situation? So if you just take a second, maybe just scan the document. Let me know if you have any questions so we can go over the questions. Yes, ma'am.
Alex Wick online has a question.
Alex.
Aaron, this is kind of just a general question and maybe a best practices question. I was trying to think of a simple way to ask this, but let's say you have a block that can do 1 ton at 180 degrees. When speccing a shackle for that block, do you need a shackle that has a 2 ton safe working tension or safe working load, or can you use a 1 ton and rely on, let's say, Crosby's 6-to-1 factor of safety? Does that make sense?
That makes
trying
sense.
to say. Yeah.
So the safe way to do that is if you know that the force on your block is going to be 2 tons, use a 2-ton safe working load shackle. That's the easy way, the safe way to do it. But yeah, as Alex mentioned, the safety factor on those shackles is quite high compared to anything that we're doing with Appendix B. We use a 1.5 safety factor to yield. Crosby uses a 5, I believe, safety factor to destruction. The Gloss and Associates have actually put out a memo about this, and they've equated the working load limit, what they generally call it on the shackles, the working load limit or the safe working load on a shackle to what Appendix B would require. So there's kind of like a table for that. So that if you have an application where, the safe working tension of or working load limit of your shackle would, if you just went on that, would be a shackle that just wouldn't fit in the equipment, it'd be too big, which often happens, then you might be able to use this to select a smaller one that's still okay with Appendix B. Does that make sense?
Yeah, so
if anybody wants that memo, if anybody wants a copy of that memo, I can send it to you. Or I can put it in the shared folder if you wish.
In the shared folder would be nice. Thanks, Aaron.
Okay. Yes, sir. I lost my mic. There we go.
If I understand correctly, you would need to use, from my perspective and looking at it, a 2-ton to hold up that block that has 1 ton of tension, 1,000 pound or whatever you want to use. If you're going to use something else that is less than that, I'd recommend you go through the safety committee to get that approved.
All right, any other questions? Okay, if there's no further questions.
Aaron, Max Kremer from UH has a question.
Yes, Max.
Hi, Aaron. Just looking at the overboard handling system manuals and other documents, who in the operator's organization is normally expected to generate these? Is it the port engineer, chief mate, marine techs? Who would you think should do that? I understand, operational requirements. Sometimes you have institutional knowledge in places where you'd normally not expect it. Thank you.
Yeah, that's an excellent question. It really just depends on your organization and who's got the knowledge to make that document. The requirement is just that the owner of the system make the document, or they're responsible for having it made. Yeah. In my organization, obviously, I make them. In other organizations, that's probably going to be different. But once again, if your organization simply just doesn't have anybody that can do this, let me know, and I'll put it in my queue.
Yeah, exactly. That's what I picked up, because you mentioned in a side note that you might be available to assist with documents like that. Thank you, Aaron.
Yeah, I am available. My queue is currently full. Nonetheless, I mean, I have to, Sekuliak is next. I got to do them for Sekuliak for their inspection, I think this spring. I got to start working on that soon. But yeah, let me know sooner rather than later, and I'll put it in on the list and try to give you an estimated time frame of when I could work on that.
Great, thank you, Aaron.
Mm-hmm.
Maybe an insight on that also is one of the last items in Appendix B is that the master is expected before leaving port to make a record or in the log saying that the vessel is in accordance with regulations. And so that gets at least up to the level of the master to look over these and look at who has responsibility.
Any more questions? Okay. So if you need help with any Appendix B related matter, or Appendix A, or anything else, engineering, let me know. There's my contact information. You can find the West Coast Winch Pool. If you search NSF Winch Pool, we're usually one of the first hits. Or you get a hold of my boss, Captain Gallagher. And we totally overachieved. That's all I've got. And we're like an hour early.
Why don't we go ahead and take a break right now, and then let's come back, and if anybody has any suggestions for changes to RVSS that we can take to the safety committee, let's have a discussion about that when we come back. So let's come back at 10:30.
Yeah.
All right, everyone, it's 10:30, if everyone can take their seats. Also, we're going to switch it up a little bit, and Jeff Garrett is going to discuss the RVSS waiver process, and then we will have discussion.
Hey, Ted, you got any expertise on how to get out of this one? You have any expertise on how to end this slideshow and get into mine?
I don't.
Oh, there we go. I need some help.
I always need help. What do you?
I want to get out of this one and then bring mine up. Oh, there we go.
And where's yours?
Well, he had the, he said go to slideshow, which was showing up there. I'm not seeing. Yeah. Oh, there it is. No, I'm sorry, it's this one. Yep. Okay, that's up there. Yep. Test. Okay, good morning, everybody. I'm Jeff Garrett. I'm chair of the RVOC Safety Committee, and I'm here to talk about the exciting subject of waivers to the RVSS, particularly Appendices A and B. So the RVSS This book here, in case you have it in an analog edition, is sorry, technical difficulties here. Okay, so the RVSS was first adopted by UNOL's member institutions in 1976, and the purpose, as it says in there, is to assure that research at sea is conducted to the highest practicable standards of safety. So I've highlighted the term practicable because really safety is a balance between getting the job done and in an economical and effective way, but ensuring safety of people and of equipment. So full compliance is a requirement to maintain status as an academic research vessel. And as Ted reminded me this morning, the safety things here are really to protect the people working on the ships and with the equipment at sea. The RVSS as a document is maintained by the RVOC Safety Committee. We discussed it, we considered changes to it, and the 11th edition of the book was pretty much a complete re-editing, and a number of changes and updates came out in November 2021. And the last major update we did just last June was pretty much an extensive rewrite of Appendix A. So the RVSS has provision for waivers requests. Research at sea, of course, is complex, involving risks to people, to equipment, ever-changing technologies, and lots of science objectives that change over time. So, therefore, if compliance is not practical or economical, a waiver can be requested. And Appendix D of the book provides some basic guidelines for requesting waivers and criteria for evaluating the waiver request that the committee uses. So what are the guidelines? It's not really a bureaucratic exercise in filling out a complex form or anything, but some things we really need to see here are a specific RVS section that's applicable to the request. In other words, what are you, having understood the project you're about to do, having read the book and tried to comply with the safety standards, is there something in there that you think merits a waiver to allow you to do the job better? What's the reason for the request? What are the operational procedures you're going to employ? What are any risk mitigation actions that you can employ if you were to get a waiver? And then finally, the benefit or benefits of the waiver itself. So if you write a waiver request, think about a committee of your peers who are going to evaluate it, and think about what you would want to know if you were going to consider this request. So some of the things that are listed in Appendix D, would the waiver, if granted, increase risk to personnel and or equipment? Is it supported by mitigation measures? Would it reduce costs, save person hours, improve effectiveness, or increase efficiency? Does it indicate a need for better clarity or changes to the RVSS? And that's important. We can talk about that if anybody has any ideas for updates or changes in a couple of minutes. Does it involve a unique situation, or is it something that might have wide impact through the fleet? And finally, would it set a precedent that may have desirable or undesirable implications? So I went back and looked at all the waiver requests the committee has dealt with since 2015, which is what we have records of. 25 waiver requests were received. That's 2 to 3 a year. Of those, we granted 20. We did not grant 1. We partially granted 2, and 2 were determined that didn't really need a waiver after all. And then the waiver issues that these 25 requests represent were 17 of them involved a wire rope and shiv grooving mismatch. In other words, primarily using 9/16 wire on a shiv that's grooved for .680 or 681 cable. Two of them involved over-the-side handling system definitions. Aaron covered that pretty effectively. 4 involved roller and shiv diameter issues, and then there was one other one. And so I was asked to provide an example. So what I've done here is kind of done a composite of the most common requests we've gotten, which was the wire rope and shiv diameter issues. And so kind of a composite type of request would be, well, we want to conduct dredging at depths up to 5,000 meters using 9/16 wire, assigned breaking load 32,500 pounds, safe working tension of 21,000 pounds with a factor of safety of 1.5. Specific section in the RVSS, tables A82 and A84 of Appendix A. Reason for the request, the overboard shiv is grooved for .680 cable, which will be used alternately at each station with 9/16 wire for dredging. So even if we could change out the grooving shells, this would be very difficult out in the open ocean on a station. So mitigation measures proposed, well, they would perform the highest tension dredging, i.e. in deepest water, only in light to moderate seas to reduce ship motion, use line tension monitoring, use weak links, use the deck and winch room procedures to keep personnel away from the impact of unexpectedly parting wire. And then in the future, quite often people said, well, we're requesting funding to acquire 9/16 grooving for similar future ops. So that's pretty much it. Pretty simple process. The one thing I would, from experience, I would urge everybody is make your waiver request as far in advance as possible. The committee tries to be as responsive as possible, but we're all just volunteers with day jobs to worry about. And what gives me chills is when I get a request that's very reasonable, but it says, oh, and by the way, the ship's sailing in 10 days. So that kind of puts us under the gun. We've been able to get everything done so far, but if we can deal with something that's 3 or 4 months out, because there's been good cruise planning and good planning in terms of knowing what the Appendix A and Appendix B require, that's really good. I'd give a shout out from the Safety Committee standpoint to our technical advisors, Rick, Aaron, and Josh, who have been really good in helping us deal with the technical aspects of Appendix A and B. They've done a fantastic job and are always there to support us when we need the technical knowledge. Most of us on the committee are not wire engineers or winch engineers, so having that technical expertise available is great. And certainly happy to discuss any questions. We're going to do that now as soon as I'm done here. But my contact information if you want to follow up with anything, general questions or whatever. So any questions on the waiver process, or when we're done with that, we can segue into general recommendations for changes to the RVSS as a whole that you might like to see. And I'll bring those. Our next formal safety committee meeting will be in April as part of RVOC, and it'll be a good platform for us to look at any potential changes to it. So, questions, comments, discussion. Yes, ma'am.
Alex Wick has a question online.
Okay.
Hey, so this is where requests would go if we're trying to operate synthetics below a factor of safety of 5. We would send those to you.
Probably the best thing is to send it to the UNOL's office, and they will, and you can certainly copy me. They'll refer it formally to the committee, and then I'll get it out to all the committee members by email.
Okay, thanks.
Okay, thank you. Oh, I'm sorry.
It seems like that, at least in my experience, the safety factors you guys use are relatively low on a lot of this equipment. Do you guys collect data on failures for kind of updating the standards or maintaining the existing safety factors?
That's a great question. UNOLS does track accidents. The data is not readily available to the committee, so we usually discuss that at our annual meetings, but it's not a data-friendly way of doing it, I'll say. There's discussion of potentially having a part-time safety coordinator in the UNOLS office, and I think one of the chief things I would ask from the committee standpoint is that they collect the data and get it to us in a timely way. The good news is there don't seem to be a lot of accidents to report, so it's not like there's a huge list of things, but yes, we certainly, as a safety committee, that's one of the things we're charged with doing, is looking at accidents or near misses and making sure we can keep the regs up to date with that.
Thank you.
Yep.
There's a question online from Max.
Okay.
Yes, hello. So I heard, or it was reported that there were a lot of testing has been done regarding grooving between 9/16 and 681, 680. That the difference is really not that significant, given that the vast majority have to do with those waivers still required.
No, Rick can talk more about the testing, since he saw a need for that and performed it. It was not that significant, so it allowed us to move forward with a change to the book, which went into effect last June. So if you look at the current version of Appendix A in the tables there, it allows some flexibility in terms of the grooving in quantitative terms for sheave diameter, sheave grooving and wire diameter.
Thank you.
Yep.
There's a question online from Lance.
Lance.
Hi. I don't have the appendixes right in front of me right now, but I'm just curious if there's anywhere in the RVSS that talks specifically about high voltage considerations, and if not, should there be, as much of a lot of the fleet is moving to things that involve ROVs or more complex gear that runs down 681 cable with high voltage running through it. That could be an area to explore, I think.
Yeah, interesting question. You're thinking in terms of high voltage for something over the side like an ROV then?
Yeah, precisely.
I don't think there's anything in Appendices A or B addressing that, and I'd have to look back through the book. I don't think there's anything specifically geared to that, but that might be something we'll look at. We could look at. If you've got any ideas on what you would like to see there, if you could maybe indicate, write that down or summarize it some way and send it to me in an email, that would be very helpful.
Okay, sure. Yeah, because I'm just thinking about things even as simple as like existing regulations talk about making barriers or signage for things that are under high tension, but is there actually anything written that says there needs to be signs and indications for, high voltage, per se?
Yeah, and I think that's probably one of the things we often see is the technology advances, the CFR rules in 46 CFR don't get updated that often, and do we need more guidance in the book? The RVSS in general, we've attempted not to copy all the Title 46, 189 CFR rules and duplicate that, but rather to stick to things that basically amplify those or extend them, or extend things in addition to what's in 46 CFR to the fleet and to uninspected vessels as well as inspected vessels. So, again, I don't know. Again, if you have any ideas on what you would like to see or what you think ought to be in there, that would be very helpful. Translating an idea into written stuff on the page is the hardest job on the committee, and anything you can detail specifically would be great. Ted, did you have a comment?
Lance, also, you run 680, 681 with high voltages to your payload. So we also should get some ideas on that, include that as well as ROV umbilicals.
Okay, anything else? How about the RVSS as a whole, not just the appendices? Anybody have any thoughts or ideas you'd like to see? We've got some time, I think, to discuss those or not, so we can move on. Again, if you do think of something, send me an email. We'll think about it. And in a couple months, 3 months, we've got a committee meeting coming up, so the timing's pretty good.
One of the thoughts I have in terms of clarification in Appendix A is identifies logging alarm conditions. How many people are doing that? I'd be interested in hearing how you do it, and what are the benefits of doing that, and how you interpret that wording. So let's talk afterwards and get some ideas. Thank you.
Just a comment on RVSS. It seems that every once in a while we get a request to use something that's like the equivalent of a fishing pole with a spectral line on it, and that would be under Appendix B because it's an overboarding tension member, right? But the consequence of failure of this fishing rod is, next to nothing. Is just, would just snap over the side. But technically, you need a maximum capability document. You need all this requirement. So I'm wondering if we could explore having making Appendix B for certain tensions and above.
Yeah, in fact, we had a waiver request in the last year or so for a small portable winch that apparently is in use quite a bit throughout the fleet, but very low tensions, a couple of 100 pounds. And so the waiver request was, do we really need to go through all the things you're doing for when you're doing 10,000 pounds or 15,000 pounds of tension? And we gave them basically a fleet-wide waiver for the winch system as a whole. Not quite a fishing pole, but it was very lightweight, didn't involve a lot of a risk of anything, and so we gave a fleet-wide waiver for that. But yeah, where you put a lower limit, I don't know. That would be a tough value. Is it 1,000 pounds or is it?
Yeah, I mean, where you draw that line is a hard question, right? But it's, as a marine technician in the field, it's hard to be like, man, you actually can't put this braking strength of 100 pounds over the side because this is not Appendix B compliant technically, So, we have to decide, are we going to be a rule following ship And I think the answer needs to be yes, and if we are, then no, you cannot use this.
Okay, what Appendix B provision would you?
Like what tension or the cutoff? I don't know. I mean,
Well, there's a bunch of requirements for training, documentation, everything that Aaron just went through in Appendix B. What is it in there that you think you couldn't do for this system, or that would be uneconomic to do? If you find something like that, send us a waiver request. I mean, that should be pretty easy to draft up, and we can certainly consider that in terms of a, that's kind of a risk-reward sort of thing. Would probably be pretty easy to grant if it's really involving no risk, but you want to dot the i's and cross the t's, which is great.
The waiver requests become a good basis to develop the concepts for the future. So by submitting them, it gives the background necessary to be able to look at changes.
Yeah, absolutely. Thanks, Ed. Anybody else? Last call? Okay, thank you.
Okay, I think it might be worth mentioning as well that Jeff Garrett currently heads the safety committee, but he will be stepping down at some point this year, and the UNOL's office will be hiring a safety officer. They like to call it the safety czar. That they will take over that position as with the safety committee, but they will also be in charge of keeping track of different changes in the CFRs, regulations that we must abide by within our fleet. So if anyone's interested in that position, it'll be within the UNOL's office.
Sorry, the safety coordinator is planned, is a planned position. I don't know if it's funded. I don't think they've begun the hiring process or anything else. And the relationship of that person, should it go forward, will probably not be a member of the committee per se, and will not be taking over the chairmanship. That would remain as a the safety committee is from the community, from the fleet, the Marine Superintendent Organization, and that sort of thing. And I think my personal opinion is it's important that it remain like that, so that it can really look at this from a practical standpoint. Who might fill a safety coordinator position? I don't know. There's certainly a lot of safety jobs around, and would be something like that. So that relationship, that's all pretty much future. So I don't want to overstep and promise it. Don't know if it's going to be funded this year. I think it is. That's what I hear from the UNOL's office. So, and I'm not sure when I'm going to phase out. So you'll be stuck with me for a little while anyway.
So it's only 11 o'clock, so we're making good time here. I'm not sure. I don't see Josh Eaton. Is he here? No. So why don't we take a break, and maybe we can start the discussion with Josh Eaton and wait for lunch to get here, and we might just wrap up early. All right, you guys, Josh Eaton is on his way. He's coming right up. So let's take our seats and we can start a discussion here in about 3 minutes.
Let's see. Is it okay if I unplug this laptop? Okay.
If it's not, here's my.
Okay. Excellent. Hopefully this will just work.
Oh, here's the
Switch to computers? You don't have to worry about it. Not sharing slides.
Right, right.
There. And then can I steal this little dongle? Go into there. And I probably ought to plug in. The laptop doesn't just decide to turn off. Sorry. Oh, way back there.
Oh, this one.
Okay.
Thank you. Just wanted to extend an invitation to anybody here that after lunch, if you would like to come by the East Coast Winch Pool, let me know, and you can follow me over. It's not very far, less than a quarter mile away, but if you'd like to see our facility, let me know, and we can head over after lunch.
How about now? Oh. All right, there we go. All right, so my goal is not to sit up here and lecture and talk as much as I normally do, because I know everyone knows I'm really good at that. But hopefully today, I'm just leading a moderated discussion. I was told it was supposed to be a round table. I'm very disappointed with the linear tables that we have. So Appendix A requirements.
hope we've already gone over this. The basics for factor safety of 5 for the monitoring logging requirements, there really aren't any. Between 5 and 2.5, 3 hertz display and logging speed, as well as a calibration every 6 months. And then once we get down to 2.5, down to 1.5 for wire rope, don't take your cables there. Rick's going to yell at you. 10 hertz display speed, 20 hertz logging with a trend graph, and calibration every 6 months. And I've got to mention, 4% is your target for accuracy, and 3% is your target for accuracy for the factor safety 2.5 to 1.5. I'm guessing there really aren't any questions on this part. And then the next part of Appendix A requirements is the wire log report, although I changed it to tension member history. So we're more, I want to say politically correct, that's not really right, but what we actually use, because we use synthetics, not just wire and not just wire rope. So inside your wire log, there should be a number of features, and the wire pool has recently put out a, or maybe they haven't put it out, but showed a sample report. And that sample report includes all of the points that I've included here. I don't think any of this is a real mystery for this, and then we'll get into report generation a little bit later. I just want to make sure that I'm in the right place, talking about the right things. So next, I did a quick survey. Yes?
Just so you're up to where we kind of talked about, not that it's the way it's going to be, but some of those, if you could go back a slide, some of those things are actually encompassed in the database.
Yep.
And so some of that history, so some of the cutbacks, the lubrication, some of those things can be documented in the database. And then the wire log, or at least the thought about the tension member history, if you will, or the log component is a subset, you know, is some of the more details, such as your max tension, max pay, all that other stuff.
Right. So I did a brief survey about what monitoring systems we're using in the fleet, and it will come as no surprise, but we're using the LCI 90, 90I, and the RPC 90X a lot in the fleet. That is made currently by Rugged Controls. We also have a few 3PS systems, which it's now owned by McCoy, as well as some vendor-specific systems that use Markey's HMI is running on Allen Bradley PLCs, and our Hobalt friends have made ones using Siemens displays. East Coast Winch Pool also has a display on the remote. That's a third party, but it's really nice. It's better than anyone else. No, I'm just kidding. And then there are some other systems out in the fleet. There's also, let's see, RAP-IDEMA has one. Is anyone here using a display or a logging device? No, not logging. Monitoring device. So actually measuring the tension and the speed with anything that I haven't listed. Okay. I think I did see in my survey there was a group that might have been using a PLC that they programmed to be capturing that data as well. Does anyone have any strengths or weaknesses of their systems that they've used? This is the part where you guys chip in. So everything we use is perfect. No one has any complaints, concerns?
Yeah, so we have the RAP HIDEMA system that you mentioned, and it's got a weakness that the data is not very accessible. We have a system, but it's generating a giant CSV that our data manager with the group can handle it. But it creates a bit of a workload for him. Yeah, and its strength is that it meets the 20 hertz. It's a lot of data, but then that's the downside as well.
Yeah.
So, comments on that?
Marty, grab a.
One thing I've seen across the fleet in terms of the appendix is that, the alarms are not automatically logged.
Yes. That's true with at least the LCI 90, 90Xs. I believe the 3PS, was it the SD50? I'm just making up these numbers. Don't ask me to verify them. Yep.
We have a question online from Lance.
Okay.
Yeah, I guess I don't really have a question. I was just gonna contribute on the Kila Moana. We have Hubble displays and systems for our CTD and LCI 90Is for our Dynacon system, which is the 681 and trawl wire. And those both communicate to our logging system. And we have like a homegrown display that like goes around the ship on various TV channels. So we have sort of a 3 or even 4 different mechanisms of displaying data, a couple for logging and things of that nature. And I'd say some of the strengths is that it's configurable such that we can set alarms and make those displayed and logged as we see fit with the manufacturer support. But some of the weaknesses is the complexity of all of that and the programming knowledge required to make changes that don't break stuff. So to get like 20 hertz displays for stuff where like you're coring or dredging or something, having filtered averages and analog 20 hertz display on top of the logging is often really helpful. And a lot of standard displays for manufacturers don't have a lot of that kind of information. So you have to sort of make your own scripts to display some of that.
All right, thank you, Lance. I'm going to jump in. I believe displaying the data only has to be at 10 hertz. It's the logging part that's at 20 hertz. And someone's going to correct me because I might be wrong, but I believe the only part that you really need to have at 10 hertz is the trending graph. Just because if your tension values are flickering by at 10 hertz, so it's a little hard to read them, which kind of defeats the purpose of them. I have some other thoughts on that we can get to closer to the end. Anything else?
So
everyone's data just... Yep.
Sorry, I was just going to say I guess the sort of the reasoning behind mentioning a 20 hertz display is that, often because it's not required, it doesn't come as a standard thing, but there are applications where it's actually really desirable to have, even if it's not required. It's just really helpful when doing certain operations.
I agree. And on that note, I'm going to share that the East Coast winch pool remotes have a trending graph that displays at 20 hertz, as well as the East Coast winch pool data program for our portable winches also displays at 20 hertz. So everyone's data is goes right where you want it to. It's nice and easy to manipulate. I didn't make it in time.
One of the things that we run into on a lot of things, so I kind of wonder how it works on this, is obsolescence. Are these all systems that tend to be supportable? You can get parts, they last, they don't break, or is it you're always trying to scramble and find parts or have to shift to a new system?
That's a great question. That's beyond the scope. But I think that's a good thing to open up to everyone. What's everyone's experience with their tension monitoring devices? Are you guys running into those issues with obsolescence? I know from personal experience dealing with Measurement Technology Northwest, now Rugged Controls, the LCI 90 is only capable of 3 hertz. So if you want to go and doesn't have a good trending graph. So if you want to go to a safety factor below 2.5, you'd have to, at the very least, upgrade all your 90s to 90Is. And I think 90Is are now out of production, so now you'd have to buy an RPC 90X. But there might be an easy upgrade path. They told me this a long time ago, and they haven't corrected me. And I keep saying it, but I believe you can use the display from the 90Is and replace the stack. And that'll upgrade to the 90X. Yes. Oh, I don't have any thoughts.
So maybe another way of asking what Josh is trying to draw out of people is that if we were to have a standard format for a wire log, and we've shown some examples, Ted showed some examples, I've shown some examples, would you be able to take your data the way it presently comes out, not handwritten, but printed out, formatted in the same format that we've thrown up on the board, on the screen? That's what we're striving for. Standardized format, not handwritten, printed out, be able to send it to us digitally, and we upload it into the database. If you can do that, then we're going to say that's the way we want it. And hopefully that's what you're going to send us. But if you can't do it, then I think that is a little bit of what Josh is trying to draw out, because we want to standardize these wire logs.
So what Rick wants, I'm going to put words in his mouth because he loves this. He wants what is received to the wire pool to come in a standard format that's easy for the wire pool to parse and understand. And have it be the same so we don't have to try to figure out what Josh's weird text file is that his program outputs.
Yes, I said that. That's what I meant to say. But also, I mean, we get a variety of formats from handwritten to things that look similar but not identical to what we currently showed. And so we want to move in that direction. We don't want to stay with the handwritten logs. We want to move toward the electronic version, and the way to collect that and format it is important. And that's why Josh is here to help us, hopefully, come up with an approach that's workable. So but we could sort of stop now if everybody can do that. And it's not an issue for the systems that you currently have on board.
So with the RCRVs, we're going to have the wrap system, and I think, and I haven't seen the actual data yet because we're still putting the ships together, but the file that comes out of the data logger, I don't know how much you can actually change that raw data, but I'm also curious about, because you have to have so much metadata of, what we're actually giving you the file for, which day is it, what instrumentation are you actually, what package are you putting on the wire? So I'm not sure exactly like how you guys want to do like the metadata as well as the data packets themselves.
So I think we'll start getting into that coming up. I forget what my next slide is, so let's find out.
Okay.
So,
Lance online has a question or a comment.
Okay.
Yeah. The challenge, I think, with making sort of on this topic is that most every ship has a different central logging system, and thereby their data fields are going to be slightly different as far as organization. Where is the, which field is the alarm, which field is the date, time, how many time decimals are there, and all of that metadata is going to be slightly organized in a different way and logged. Maybe it's Julian day, maybe it's per cast, things like that. So I think the challenge is that each operator just needs to have some sort of scripting mechanism or method in which to collect the standardized data that the pool wants. But I would see it to be a huge challenge for all the ships to have the same way of generating that data, I guess. Not all logging systems are the same.
Right. And I think the goal is to get to the same end result, not necessarily everyone follow the same pipeline to get to that result.
data processing, and as a result, reevaluating immediately when it was brought up, the idea on the wire school website and stuff like that, or the database, something that changed my mind for me, tech operation, we don't have access to internet. Having a format, some sort of an Excel document or something that's formatted in a way I want, we could then, write our code to translate the data that we're receiving. And I'm not sure
Yep.
has remembered that, and I believe that.
Yep.
With some stuff, so like things like that, we're able to share the way that we're doing those in various methods. There's only so many out there. We're not all going to be individual. There is
Right.
some overlap. Try to collaborate the way that we have this whole free guide. I can see that being us as well.
All right. Thank you. All right, so I think we got a little bit of ahead where I was trying to moderate us to, but that's all right. I'm not going to place blame on everyone except for me. No, I am. No. So anyway, our systems put out data in various methods, from none to serial to network to CAN bus. And then there are lots of different strings that get slung around the ship, including one that I made, the UNOL string that meets Appendix A requirements. It includes a little bit of extra information that I've been trying to get vendors, hey, when you build something new, let's put this in. And then everyone knows what that string is, but I think I just created another standard, that XKCD comic, I think. Let's create a new standard. Now there's 19. Oh, sorry. All right, so next up is the display. And there are operator displays on the ship. According to Appendix A, your operator should be seeing a trending graph. The LCIs 90I and 90X do that. East Coast Winch Pool Remote does that. The East Coast Winch Pool Data Program does that. Many ship display programs do that. Winch manufacturers do that. I'm not entirely sure about the 3PS systems because I don't have one to play with. But I think you guys do. It doesn't do the trending graph? Okay. So next is how we take the data from the winch itself, and then we log it, store it, and write it down. And I think this is the place that we have probably the most variability between operators because each institution seems to do it differently. And so there are a few proprietary systems that are developed by the winch manufacturers, such as RAP, and I think there might be a couple others that are skipping my mind. But then there's also the WinchDAC software provided by Rugged Controls. Although on my survey, someone said that they have new software now. I don't know what that is. For some reason, they won't give me a copy of the software to play with. The next place that data can be logged is in data acquisition systems. So SCS, OpenRVDAS, the KM's custom DAS, and I'm sure that there are others as well. And they are easier or harder to ingest data from different devices. And then next up is the other category. And my favorite is that we only log it on the winch. So if you just use your LCI 90Is, you put the compact flash cards, if you still have those, into them, you can log directly to the winch. Our portable McCartney winches log directly to the, actually all of our portable winches log directly to the winch. because we don't know if we're going to hook into the ship systems or not. And in order to facilitate that, I did write the East Coast Winch Pool Data Program to translate data from our winches to something hopefully more easily ingestible. So we finally caught up to what we were all talking about, the wire logs. There is a subset of group that responded to my poll. They said that they made it up. That was the 7.1%, and that was the same percentage. Oh, they were consistent, and I can't remember who it was, but they said something else they did, which seemed a little funny. There was a not insignificant portion doing it by hand. Digitally, manually was also a method, such as you gave a digital report, but you sorted through the data manually, or with a program, you found your peaks and put it into your software, and then a smaller subset was doing it automatically. You hit a button, search through, and it generates, it spits out a report. East Coast Winch Pool program does that based on parameters that you can set. And as I said, Rick loves my format because it doesn't make any sense to him at all. So I suggest we all start using, no, I'm just kidding. So those are some of the things that are currently out in the fleet. Rick would prefer to be having the end file be a digital Excel file, or maybe even a CSV would be acceptable, as long as it was standardized across the fleet so that it could be ingested by the database in a standard or easy fashion. Comments, questions, concerns? And then I also asked, how often are we running our data logs? It won't come as a surprise. Most people were at once a year because that is the requirement. There were a few that answered when Rick yells at us. So get your logs into the wire database. I don't think anyone was doing it every day. No one was running a cron job every night, sorting through and making their file. I run them post-cruise, and I only say that because my winches only go out for 1 or 2 cruises, and then I process the data because I'm probably changing the wire off the winch pool winches. Does anyone have a preference on the kind of workflow? I mean, since I'm not doing it yearly, I imagine that's a lot of data and it's a big file to generate. Yes. Oh.
I was just going to say we end up doing it post-cruise because we store that data with our data package, which is, not an R2R requirement, but I don't know if any other groups are treating that as part of the data package as far as keeping it associated with the cruise.
So you're processing, you're making what you send to Rick every month for your wire log that goes into the wire database, or are you just bundling your data?
Mostly what we're going to send to him, it's kind of a new thing that we're trying, but it's effectively all of the same data because it's the summary of the casts for that cruise, which is effectively, we would then go and summarize the time frame, which would be a year-long time frame to actually send to them.
Okay.
So they're a little different, but they contain the same information.
All right, so you kind of do each cruise, and then you take those cruise summaries and make up your year report.
Yeah, but we're not like aggregating those. We create a year report based on a date range.
Okay, so you're taking all the data, saying,
yeah,
and processing it then. Okay. Anybody else have any interesting workflows? Data retention. This has always been a question, and Appendix A does not answer that question. How long do you keep the data for? Again, in my survey, most said forever, because we don't know what to do with it. Which ties into the next question, is uses for the data. And most of the people said they only generate wire log reports from it. Generally, I only keep mine post-cruise because I download it from the winch, I process it, I send my ugly file to Rick, and then I want to clean off the winch to make sure that if it goes out for 2 or 3 months, I'm not losing any data because my storage is very limited. Anyone else have a feel? A year? More? We just buy new hard drives when we need to add more data. So there is no requirement to keep that data. I'm not saying it's a bad idea to keep it. And if you wanted to, you could compress it, depending on the type of files and the file sizes you guys end up with. You could just keep the maximum tension from every second rather than storing the 20 data, which might be easier to process. You want to go back and look at it, and because generally we are interested in the peaks. So what is everyone using the data for? There's no one to race on this side.
From observation from the fleet, the place I've seen it used, if you have a incident or something happen, and I'll use the example of one of the vessels dropped a CTD, two-blocked it and dropped it, and they wanted to go back and analyze the specifics on a short time basis. The high-speed data was used for that purpose. So if you have an event, it could be very handy.
So personally, I've also used the data to analyze active heave compensation. And I would love to have more of that data, but I also need MRU data, the winch data, and a CTD for depth. I don't really care about the rest of those values.
Yeah, so a couple of times post a cruise, we've had, particularly in piston coring, we've had scientists come back once they've started scanning the cores and had anomalous findings in the cores. And so they wanted to back out and look at some of the data to try to figure out if something had happened strangely with the core penetration operation. So usually if it's in the cruise log, that's a great place. They already have that data, but that's a place.
All right, so that brings up the data retention, that it is good to keep it for a while. Sorry, everyone. I'm still deleting mine. Yes?
Is it hot? There we go. It is lunchtime right now. So Josh, if you find a good spot where you think it would be good to halt and we can all grab our lunches. And I'd like to know if people would like to have a working lunch, so we keep discussions while we eat, or we can take the hour. So those who would like to have a working lunch, raise your hand. Okay, those who would like to take the hour, raise your hand. Great, okay, working lunch it is. So Josh, whenever you're ready.
Great. This is gonna be fun. I apologize if I spill out food while, no, I'm kidding. All right, I think we're at a decent place if no one else has any comments on what they use the data for. I think those were a couple of good points. Yes?
wanted to add one other use will be looking at the history of a tension member, particularly a synthetic member, and working with the manufacturer and making the determination as to whether we can lower that factor of safety down to the point where some science can actually be conducted. That's part of the reason for knowing a little bit about the history, the loads that it had seen previously, and to what degree that has helped deteriorate the wire or the rope, and how it can be used in the future.
Now, just as a question, is that just in the just the data that you're receiving? So you're not looking at the full wire logs, the full 20 hertz data for that?
I honestly don't know what will be the peaks. I think the max loads and where they occurred within that line are what we're looking for. And so if in order to get the peaks appropriately, we need the 20 hertz.
Yep.
But as far as logging it for long term, right now I don't have a use for that.
And you don't, I guess my question was, do you want the 20 hertz data for those synthetic lines or only the peaks, would be my question.
Well, I think that's a question I'll have to try to get an answer to from, say, the manufacturer, whether that would be useful or not. But right now, I'd be happy with the peaks.
Yep. Anyone else want to chip in? What else they use data for? All right, so we're just throwing it all away. Okay, great to know, great to know. I'm kidding. All right, why don't we break here for lunch? We'll take a couple minutes, and then when I start speaking again, you better be seated. Oh, that's all right. Ran outside, my Jeep wouldn't start.
Was it cold or what?
I don't know. It could be electrical. right, has everyone had a chance to get what they need? Those lazabouts that haven't come back, and I noticed Rick, and then, why am I blanking? Ted. Oh, here they come. All right, so this is the last topic, I think. I don't know. I finished making the slideshow this morning, and I can't remember if this was the last topic I put in or not. See if that's up a little bit higher. No, that's there. Maybe that's not covered by anything now? Is that okay? Great. Press the wrong button. All right, as I mentioned previously, ships aren't the only one that the wire pool wants the data from. They also want it from my winches. Who knew? So we are logging the data. Then the question came up, was how do I process this data? So I started working on this program that processes our winch data. That's all it did. And then someone sent me another log file for another winch and said, hey, Josh, can you process this? And I said, yeah. So things kind of kept getting a little bit bigger. And then there was a science party that came in and they said, oh, really wish there was a way that you could put that data in the lab. So then I added a graphing component and data display. And currently, I am working on getting it to collect wire history. These should all be, oh, sorry, I pressed the wrong button. I was shooting lasers. These two are being worked on concurrently. The program has done a lot of work on it. And it's slightly different than it was before. Hasn't been released yet, but it should be released shortly. And back to that point, fairly, well, I don't want to say this, but if for those ships that are interested, I can probably add your data into my processing system, which would then automatically generate cast logs with the press of a button. Something that then Rick and I had talked about was inserting that data directly into the database. I mean, not through proper channels and all of that, but making it so you didn't have to upload your PDF files, that it could just be, you put your login credentials into the program. I'd never know what they are. You know, the wire pool database is a high value target, so everyone better do their best to keep that secret. If there's interest in that kind of thing, that would also be something to talk to me about. Yes.
There's a question online from Lance.
Every time, Lance.
Yeah, I know I'm chatty today. Um, Over the break, I had a thought, something that we've recently looked at, specifically when it comes to something like a CTD, where the ship isn't really towing something. A valuable data point to track when it comes to winch logging and sort of to advocate for holding on to data over some period of time is to look at what your wire out is in relation to a really well-known depth of some location. And if you're going to the bottom, for instance, like you're going to be 5 meters off the bottom of the seafloor in an area in which you're really confident in what that depth is, looking at what your wire out is telling you at that spot over time. And you can then track whether or not whatever system is telling you wire out, whether it be some sort of logic or whatever else, you can see if that starts to drift. So if your wire out starts to drift to where you're 150 meters more wire out than there is depth, when really with catenary and everything else, you should only be maybe 20 meters difference, something like that. I think it's a valuable data point to keep track of.
Yeah, that would definitely at least indicate where you should look if your monitoring system is having an issue. You'd know to look at the payout sensor, make sure that they're configured correctly, make sure that they're working, making sure you haven't lost a magnet on your shiv. Any other comments, questions, open discussion, fancy finished? If anyone is interested, I can start my program and put it on the screen if there's people that are interested in seeing. Yes? Every time, Ross.
So you have new logging capability on the winch pull winches, right?
Yep.
And so we all are pre-planning meetings and what have you, and your scientists decide this is what we need, this is what our operating conditions, et cetera, et cetera. So maybe this is like getting a little too far ahead, but if you send a winch out and they decided that they were going to work under a certain factor of safety, and then you got the winch back, would you look to see whether they did what they said they were going to do?
See, this is the malicious compliance. Is that when I receive what factor of safety they're going to be working under, I then set our auto render to not that value, but around just above that value. And then when I get a call in the middle of the night saying, I don't know why our package keeps falling, I already know what they're doing. But yes, we do look at the logs to make sure that they are operating within the bounds that they're supposed to be operating in.
Okay, cool.
Anything else? Oh, no.
I'm going to put the Antarctic program on the spot. I talked to Ross before. They have a situation that's rather unique, that if it exceeds a certain tension, it sends an email out identifying it. You want to speak to that, Ross? Or
Yeah, indeed. So this is something that we set up in our program a while back, and part of it was getting it more in the scientists' visual area of what's going on. So we would identify tensions as green, yellow, or red, and that's how the display was. And so you're running in the green. If you spike over that, everything turns yellow, and you hope to never see red. But if a yellow gets generated, a yellow tension event gets generated, an email goes off the ship from RVDAS titled Winch Analysis, and it'll have what winch, what strength member, GMT time, location, wire out, and tension. And so it went from back in the day of you wouldn't hear about these things until maybe the end of the cruise or something like that. But in the morning when you're having your coffee, you see that you have your events, then you check your email, and the explanation's usually already in your queue. But that's been a powerful tool for us, is keeping track of all that stuff, because it comes up. And, you know, if you get into the red, it helps give us a little more teeth to shut the operation down if we have to.
Does anyone else have a process that's not necessarily like that, or do they have a process in place to keep things in check as far as tensions and convincing the mad scientists? Well, they're mad because you're asking them to stop doing CTDs, not because they have mad hypotheses. No? Okay. Should I start up the latest version of my program just to give an overview of it? It's not as colorful as it used to be. Kind of boring at the moment. But as you can see, there is a place to put in cruise information, ship, select what winch. I'm guessing most people aren't going to have quite this many winches. But I do hope that you have great names for your winches, like we do. And then it lets you select them. And on here, you can see maybe you can see there are red and yellow areas for the Appendix A warning level and the Appendix A alarm levels. So above that goes red, between the two is yellow, and below that is normal. And you can plot multiple winches. You can resize the text display. And it'll just keep stacking them. It becomes useless after a while. So I certainly wouldn't recommend doing too many. Unless you have a really big monitor. But the winch configurations are all done here. We can put in the winch name, winch manufacturer, and model, which I believe Rick had in his wire log report. Tension member information, and with the Appendix A safety factor, it will automatically calculate out what the warning and the alarm tension should be. How you want to log the data. If you just want to log the max data, this will do that and automatically generate a cruise summary. And then how do you talk to the winch? Do you want to send that data on? Again, part of the purpose of the program was to allow ships, if they so desired, to integrate our portable winch data into their data stream. Just so if they wanted to include that in the data package, trying to make that a little bit easier. And then finally, a wire log entry point. So this will be attached to the tension member. And you can put in a log event, and you put in the date. You can add that. Again, like I said, I haven't finished. That's why it says data grid. A data grid's going to go there. The next part of interest is the processing. And so you can select what winch it is and select what type of file you want to generate. The Excel is supposed to be the wire pool preference. It will then give you processed file names. You can set what your limits are to determine when a cast is complete. This is kind of a tricky thing. At least in my experience it is, because it seems like some ships might leave a little tension on just to keep everything secure. I think most ships probably don't and leave it loose, so the tension should be 0. The question is, how does load cell drift? So I have 2 parameters to hopefully narrow that down. The minimum tension for it to be considered a cast, and the minimum payout for it to be considered a cast. So you could go, when it goes negative, then we know it's no longer a cast. But there are some weird circumstances where you might want negative data, in the sense if you have a Lars bringing it on board, when it comes up to the surface, it's going to be at 0, and then when you lift it up out of the water, it's going to be less than 0. So it is possible that you may want negative payout. And you can also see my very nice plot view and another data grid there. So those are coming along well. And finally, a link that says download the latest version. And the only time it calls home is when you press this button. And right now I'm getting an error because I haven't wired that up right. But it'll swing out to GitHub and check to see if this is the latest version. This doesn't look good. Shouldn't have done that. So if there's interest in this program, even in part of it, feel free to talk to me about it. It is, again, available on GitHub, and let me take a step back. I'm a mechanical engineer, and this is a program. I make no big promises on how great my programming skills are. So if anyone really wants to dive into it, you can come aboard my GitHub team. Well, it's C#. So all the C programming, C++, easy to get into. Great, lots of volunteers, thank you. But again, if anyone has an interest in the program or any part of it, let me know. And we'll see if we can make it fit for you. Anybody else have any comments, concerns? They want to discuss the way that they process the data, complain about different winch manufacturers on how they output the data? Yes.
Yeah, I think this might be more a question for Rick, but I was wondering if you had an example of somebody who's reporting data to you really well, and if you could share that example, like not maybe you can email it or something like that, but of the format in which is the way that you'd like to receive the data.
I think what I was saying is that there are some folks who are doing a pretty good job. Nothing specifically comes to mind right at the moment, but the format I think that we would like to have is similar to what both Ted and I showed with those parameters that we showed, including it's not what I want necessarily, it's what's required in the appendices. And the variables that they list are what I included in my template. We need something that includes the shiv train, what the identifier for the cable, what winch it's on. I'm just from the top of my head, but the date that the cast was done, the max depth, all those things that we included. I mean, it's not like anyone is doing it now. And as I said, we get a variety of formats, and the hope is to be able to standardize the format, include the variables that are listed in Appendix A, and be able to use this information. I know Barbara looks at the logs when we get them in before she does a brake test or does a brake test. We're looking for max tensions. Has the tension member been overstressed? One of the issues. But now, as we get into the synthetics, we're hoping that we'll have a better history, more consistent history on the way that how the synthetics have been used. That's the best I can do to answer your question.
So I think a question is, can you make that sample available?
We have shown it.
But can you make the template, the Excel template, available? Could it be put up on the Wirepool website?
Sure. Yeah. We can do that for sure. Gotta get my steps in.
I was also going to say that format, if it can be something where you can export it as like a CSV or text file. I know there's the way it looks right now, it kind of has I guess it doesn't really matter if there are those in terms of the formatting, but yeah, if we can just make it as plain text as possible, that would be the easiest for us outputting. I hope with yours it would be the same way.
I'm hoping that I'm going to be able to output an Excel spreadsheet.
But that's just like a CSV with.
For mine, it's going to be essentially Rick's sample without the shiv train. I'm not entirely sure how to generate that picture programmatically. But it would be an easy thing to say, use this picture, and it would insert it into the file. I'm really hoping that because C# is written by Microsoft and Excel is written by Microsoft, that I'll be able to get the right things to work and that I'll be able to make a spreadsheet. I have it prototyped, I just haven't written one yet. So in a little while, I will know, and then I will post on the RVTech listserv when this version is released. I don't want to spam the list every time I put out a new version, so I don't think anyone's looking there to know when that's put out, but to reach everyone, that's the easiest way. And once I finish this, I will put it out to the world, and then everyone's going to tell me what I'm missing. It's going to be great. So I guess the question for Rick is, could it be a flat text file if it just had those parameters? So rather than having that format, it would just be comma separated Oh, that's what we should have done all along, is let you have one. Because Rick just asked me to do this because he didn't want to stand up here again, so.
I am by no means someone who can answer that question as far as what do I do with the data. You give me the data, tell me how to put it into some format which is recognizable, that we can pick off the appropriate variables, not the way you provide it currently, but
great.
a way that I can interpret it. That's fine. We just need the data in a format that we understand. It doesn't have to be the way I show it. Having it as an Excel file is helpful. If there's a way to convert your text file to that stuff is beyond me. And with help, I imagine I can do it, but I don't know I don't know the right questions to ask, except that I want the format so we can understand and have it uniform and include those variables that we've talked about. Probably doesn't answer your question, but that's where I'm coming from. My needs are very simple. It's what, in order to get there, that I want you to solve. So I have a question. If I have a boat, I've got this huge research vessel, and we sail all around. We do CTDs, we do coring, and I want to put your system on my boat.
Yep.
What's that going to involve?
If it is...
And I have a LCI 90 currently doing something. I don't know what it does, but I wrote down those
letters.
Those letters.
And numbers, yes.
It makes me sound like I might know what I'm talking about. So now, what do we do? This sounds like a great system to me. I don't know anything, but what do I have to buy? What's the hardware? What's it look like? What's it going to involve? Do you have to come and install it? Blah, blah, blah.
It depends on how technical you are. Rick, for your ship, I would definitely have to come. So make sure you budget that in, my time and my travel. It should be relatively easy. It is theoretically cross-platform. And when I say that, it runs on Windows, it runs on Linux. It compiles for Mac, but I don't have a Mac to do the final packaging step. Why that isn't easier, I don't know, but right now that's where I am. I put in a proposal so I could get a MacBook so then I could make it actually fully cross-platform. So to get back to Rick's question, what do you need? You need a free computer or a computer that it can run on. Preferably it wouldn't be an LCI 90 because then you'd only be getting 3 hertz data, not your 20 hertz data. So let's upgrade to the 90i first. And then the 90i can put out data on the network, and so you can set it up to receive that data. And I believe it can either be through TCP or UDP. Not me.
If I don't know, from my other, how am I going to do it? What's the, I'm really trying to figure out how difficult this is. Is this easy? And how much is it going to cost without your labor? Is it an expensive operation? If I'm asking questions that everybody else is laughing at why is he asking such stupid questions? Just tell me. But I'm trying to get a grip on what it's going to take.
All right, so the program is free because I'm developing it on NSF's dime. So when our new program manager comes, they'll be excited to find that out. So it's free, it's available. Again, if you want to look at the source code, feel free, it's up on GitHub. To set it up, all you'd have to do on a Windows computer is download it and run the executable file. On Linux, you would need to set it as executable, and then you can run it on your Linux system. chmod 777. I don't know. It's been a long time since I've used a Linux system. And then you would need to put in your winch information. So you could put in a name. We have Mo, Larry, Curly, and Shemp. And then you'd put in your tension member information. And if I say 2.5, like I said, everything hasn't been hooked up quite yet, but our alarm tension comes up and it's going to automatically adjust those values in the chart. And then we say, what do we want to log? We want to do the 20 hertz data. And then, because this was developed for my use, there were two things I was interested in, either the format that I wrote or the MTNW1 format, as opposed to the MTNW legacy format. And we're not going to talk about 2 and 3 because those get confusing because you can have multiple winches in them, and it's really hard to parse. I don't have a way to really specify anything. And then you can choose either to use computer time or whatever time the winch is set to. And you can even set what units it's going to display, what units the data is going to come in. I don't do any data conversion. I'll leave that to you. As an exercise to the reader, as my professor used to say. Next up, you'd have to know your IP address and what port you're sending it out on. The Hobalt stuff, for those who have a Hobalt winch, are tricky to deal with because their data is in raw binary, so you have to translate it into ASCII. Anyway, it's a pain. I should be doing it. I need to talk to you guys again to make sure that it is doing it. If you already have a logging system in place, you can send the data from here, again, set in the IP address of SCS or OpenRVDAS, or I don't know how those work because I have never had to do that, but I figure this will work. Or you can send it out as serial data. And anytime you do a cutback, eventually this will have a list of things that are typical. Or you can just install the program. You're already collecting your data however you're collecting it. And then you can come in and you can say, all right, we're going to use a MASH winch, and the cruise is Trask 1. We're going to set it to 12 and a minimum of 100. And if I select this directory, ooh, oh, that'll be fun. It's a two-step process at the moment. I probably will make it a one-step process. And once plot view and data grid view, excuse me. Once the plot view and the data grid view get put in, it will display the data. Excuse me. Press a second button, process CAS, and it does that. Currently, we end up with my wonderful file. Let's see if I can find it. Oh, good, I did that. Don't tab shame me, because I have 1,000 open. Currently, this is my ugly file format that I'd love to torture Rick with. Well, I don't, how come you didn't tell me that sooner? Then I wouldn't have done this. But right now, it's just I take the strings and I take the high tension string and the max payout string and attach those to cast numbers. And once I finally, make this work, it'll be an Excel spreadsheet in a format that's easy for Barbara, but difficult for Rick. Yes, it is. It turns out this is the UNOLS string, and it turns out those fields of zeros are spots where alarms and warnings can go. Yes.
Lance Online has another question or comment.
Every time.
I guess my question branches from this a little bit, but my question is, what are the steps and or are there instructions that come with East Coast winch pool winches, or any winch from a winch pool, to take the raw tension data and output that to an existing ship's logging system? So essentially, how do we get what it's just collecting once it shows up and get an output into, whether it be serial or UDP or some other mechanism, into the ship's existing logging system?
All right, so this is branching off a bit. So those that aren't interested, you can take a nap. No. So if you receive an East Coast winch pool winch and you would like to collect the ship's data, the winch has a Ethernet port, a IP66, but maybe it's an IP69K connector for Ethernet on the side. It is right above the joystick or the remote control connector. And if you plug in our waterproof connector and plug the other end probably into a waterproof coupler and then plug it in somewhere to your ship's network, the winch will get a DHCP address from you. Inside there is a VPN router. So this does two things for us. One, which is non-germane, and I'm going to tell you about anyway. It lets me connect to the winch from home if you let the winch connect to the internet. I can then dial into it and do, depending on the winch, I can do some amount of remote diagnostics. But back to what is germane, if you know the IP address, and I hope our technicians can find the IP address of a new piece of equipment coming onto their network. If not, you guys are going to have to talk to the IP security team. I forget who they are, but you should talk to them. And if you take that address and put that into my program, let me pull that up. Into the winch config, and you say incoming data. Well, I have it on IP address 192.168.1.141 currently, and I always use port 50505 because it's my favorite. And the default answer here should be what talks to our winches. I can't remember if that's TCP server or TCP client. But that's the easiest way to get through. So this program will run on the lab side of the ship network. It will then connect into the winch, but it has to go through a firewall on the winch. And so the easiest way to do that was TCP, because I couldn't do broadcast UDP, and you don't want broadcast UDP across your whole network anyway. So TCP connection works well for that. So if you put that in correctly, you can then come over to live data. And it's a shame that I don't have a winch connected right now at the winch pool, because I could run this live, but I didn't think that far ahead. But after that, yeah, you should be able to plot the data here, and if in your winch configuration you said send UDP data and you put your target address, so whatever your ship data collection DAS is, along with the port number you want, and the formats, which I believe I package with the program, and if I don't, it will be in the future, because I just said that I would. So you can then take that and put that, ingest that into your own DAS if you so desire.
So is it accurate? Is it accurate to say then that in order to get winch data from these portable winches, we need to be operating this software?
No. If you wanted to, you could just put in if you can configure a TCP connection the proper way of, and I forget which one needs to be the server and which one needs to be the client, off the top of my head. You could then automatically talk to the winch. The trouble is not all of the winches speak the same, because that's one of the reasons why I made the program, was so that the output could be consistent. So our MASH winches output an MTNW legacy string, and our small Hobalt that East Coast Winch Pool did the controls of does the UNOL string, and our large Hobalt, Godzilla, does the Hobalt thing, which you don't want to have to deal with. And I mean that in the nicest, kindest way.
Okay, so then the port on the side of these winches is, plugged in directly to whatever the winch controller is, not necessarily a separate bit of, East Coast Winch Pool computer on the inside that needs sort of a double intrusion kind of thing to get winch data out. It's just, if you set up the TCP right, then you should just start getting winch data out.
Yes.
Perfect.
And again, it's just a matter of which winch you have. If you have one of our MASH winches, it'll be the MTNW legacy string versus the UNOL string. Anything else? Anything that I can bore you with? All right, everyone, if you want to come up to the East Coast Winch Pool shop, you are certainly welcome to do so. It is up on the Quissit North campus. It is very exciting in there. We have winches. If you have, yes.
John Zand has a question or a comment online.
Okay.
Yeah, hi Josh. On a Nautilus, we've been trying to figure out a good method to predict the tensions that we're going to see at depth before we launch, and also have a good operating procedure to, when we start seeing high tensions, when do we call a dive? It's good to have that kind of quantitatively so that when a chief scientist is like, no, we can just keep going, we have a solid method of shutting that down. Does the winch pool have anything along those lines as far as we can work together on correlating, you know, the tensions you're going to see to what your A-frame's acceleration and velocity is going to be?
This is a very interesting question, which is a way of saying, I haven't thought of your case yet, but I'm going to speak off the top of my head. So as far as estimating what your tensions are going to be, if you have historical data, that's going to be the most accurate. If you do not have historical data, then the next line is to ask for some if they've done that operation on another ship. Now, if you don't have that because it's a brand new instrument or the ship they were on sunk, not that I'm hoping that for anyone. Data's gone. You can do a calculation for what you believe the drag to be, and a first order approximation should be good enough for this. So you can take the mass of the package, the mass of the entrained water, the mass of the package in water, or the weight of the package in water, along with your wire out, is going to give you your static tension. And then if you take the mass of the package, the mass of the tension member, and the mass of any entrained water, you can then use a gravitational factor, which in ABS parlance and in Appendix A, it is said to be 0.75. I don't think you want to be seeing anything more than that as far as the motion of the ship. So 3/4 of a G, and that's the Appendix A method for guessing what your tensions will be.
Your schedule today. Okay, yeah, we were we try to push, like, we try not to operate in 0.75 G. We try not to find ourselves in 0.75 G, but we definitely don't try to operate. It's more like we have acceleration, like we have, you know, an IMU on board, so it's easy for us to know what our actual accelerations are, and we can look at the weather pattern and say our accelerations are likely to decrease or increase based on what the weather is doing. I guess what I try to do this a little bit with the Nautilus data, and I'm trying to figure out if the model discontinued. The problem I'm having with modeling, based on what you just said, is am I seeing significant stretch in my 5,000 meter 6-8 cable, or do I have a synchronization problem between my IMU data and my winch tension data? I'm kind of going down a rabbit hole here.
That is a question that I have as well. And unfortunately, I only have one set of data on that because the cruise that I went on to get multiple data sets, time was short, and for some reason, I was just an ancillary project. I didn't think I was important. Anyway, so I think, you know, as far as estimating what you want to work in, you guys know what your actual accelerations are, and you know the actual accelerations that you don't want to work in. So if you set a maximum limit of what the comfort is, you can then carry those estimations using that number along with the masses that I mentioned before. And that'll give you a good approximation to know when you're reaching those limits. The way Appendix A is worded is just look at the values of your actual readings and go from there.
Yeah, and so I guess I'm curious, so there's no guidance on, like, hey, we're seeing values that are, you know, we should operate to a safety factor of 2.0, and we're seeing tensions that are pushing us down to a safety factor of 2.1, 2.05. Are we, we just continue on until we exceed that 2.0? Or do you, like, we're on the Nautilus, we're trying to say, okay, well, if we see like 5 peaks over 16,000 pounds in 10 minutes, we should try to get to a location that is reducing our tensions.
So my answer would have to be, you can operate until you get to a safety factor of 2.0, and then you need to stop. That may or may not be a good idea, because if you're in a worsening sea state, on recovery, it's probably going to drop below that. So you need to look at the circumstances. I haven't had to come up with a formula because no one's asked me to do that. But yeah, I'm certainly not opposed to continuing this discussion. So if you'd like to, we can.
Yeah, great. I'm happy to take that offline. If you guys want to break now, but I'll send you an email is what I'm thinking.
Okay. Yes, Ted.
In that case, probably you want to go to the alarm level rather than the 2.0. It gives you a little bit of buffer there. A question for you, as we look
Warning
at
level?
the alarm,
Well, you should have, the alarm level is at 2.0.
warning level, sounds good.
Nomenclature.
Looking ahead, and not as a limitation of Appendix A, there's a minimum required in Appendix A, but looking ahead for situations like this, how hard is it to add additional parameters as the purposes of the operator, such as weather conditions, sea state, depth, as Lance mentioned, to the data file, your 20 hertz or higher data file?
So adding that data directly to the winch data is a very manufacturer-specific question. Adding that to my data is doable, but I haven't thought of it yet. You shouldn't have. It certainly would be possible to correlate values across programs depending on how accurate you want it, because then we have to talk about time, and that is beyond the scope of this discussion and any discussion that I'm part of, because yeah, once you get down to millisecond levels of accuracy, things get terrible. And trying to match up 20 hertz data is quite difficult. Again, if I had more data to play with, I might have come up with an answer to that question. But with the MRU data, the winch data, and the CTD data, I was never able to fully match up cast, such that I saw the heave that I measured with the MRU, and I could take the heave that was measured and take the CTD depth and subtract out winch motion, or subtract out the heave from the winch motion, and I should get the CTD depth. I have not successfully been able to do that, to get it to know that I'm right on at 0. Theoretically, you should be able to. So again, it's a question of precision or accuracy. Yes.
Ben Duncan online has a question or a comment.
Okay.
Yeah, hi. Earlier it was mentioned by someone that they use a email alert system for their wire tension. We've been interested in some sort of push alert system. So I'm just curious, like lately we've been looking into Grafana with their on-call app for doing like real-time push alerts. I'm wondering if you've seen anything like other systems people use, or if anybody has any suggestions of what they do for some sort of system like that, whether it be wire out, tension, just different parameters you could set for real-time alerts.
So I have not set up anything like that. I have not seen anything like that. But again, depending on what you're using to set it up, email would be the easiest, I would think, just because most program language have a hook into SMTP. Beyond that, doing push alerts across Wi-Fi I cannot answer that question because I have not done that. And I'm assuming USAP is doing something similar to what I mentioned for the email alerts. It's just that they're looking for above a value in the tension, and it takes that and sends it off in an email.
Okay, thank you.
But if anyone wants to tackle that problem, share it with everyone. That would be great. That would make a great RV tech talk. And, it would be really nice to go into your promotion files at your institution as well. I'm not going to look into it. Any other comments? Discussion? I'm just making this stuff up as I go along, so better if we discuss it and figure out where I'm wrong. Okay.
Looks like Lance has a question online.
Okay.
Yeah, as long as we're just in let's talk about stuff mode. I'm curious if you have any insight into load cell calibration strategies. For instance, we have a LCI 90i system for our A-frame load cell, and LCI 90Is give you the opportunity to run a 2-point or multi-point calibration. And so assuming that you have a water bag kit and assembly to just get to the tensions that we need to get to, such as 21,000 pounds as the high point, what are some of the disadvantages or advantages of 2-point versus multi-point and sort of the 3% tolerance for that load cell?
All right, I'm going to start off with saying I don't actually have a good answer to that, but I will share my thoughts on it anyway. That's why you put me up here, so I can do that. So I think 2-point is probably close enough. And a couple of things to remember that there isn't a specification on where that calibration has to take place, at what tension that calibration takes place. So you need to ask yourself, where do I want that accuracy to be? And if you don't plan on going to 21,000 pounds, maybe it's not of interest calibrating up to that high. So for my portable winches, I calibrate to what I believe the working tension shall be, or just above that. And that's where I aim to have my accuracy. I don't care if my 0 is accurate because it's 0. But having that high point be accurate is important. And as far as calibrations go, I do need to mention that you do want it in an operating position. So you don't want to just hang a water bag from the A-frame, unless that works out right for your application, but you want to have a tension member strung through your system because that's going to change the forces that are on the system. Unless you have another winch or something and pull the water bag so it makes the right vectors.
No, great, thanks. Yeah, that's good information. I'm curious if what Ted and/or some of the regulation people think about where that 3% tolerance point should be as well.
The 3% is based on your heaviest load that you calibrate at, or where you maintain it. So if you're running a low value compared to the capability of the overboard handling system, your error bounds become pretty thin. So the 3% or 4% are based on the applied load. And for example, for the, say, a CTD operation running at 2.0 or 2.5, you'd like to find probably a weight in excess of, say, 4,000 pounds, maybe close to 5,000 pounds, because that gives you the most, the largest error bounds to track in the aspect of maintaining the tension member system. And just offhand, recalibration periodically does not meet the requirements of maintaining the calibration. Does that answer the question, Lance?
Right. Yeah. Tracking in just a 6-month, look isn't necessarily keeping within percentage, but I think you answered my question, which really comes to, where are we putting that interest point? Is it the max capability or the expected load of a given operation per cruise basis, for instance? Like if we're going to go out and do a dredging or a piston coring operation with trawl wire or something in full ocean depth, we're going to have far higher loads than if we're going to hook up a giant net to the trawl wire that for whatever reason we had to do that. And the load is going to be something like no more than 2,000 pounds, right? And if we run with a calibration for 20,000 pounds on an operation that's never going to go above 2 to 3,000, then our calibration is not going to be in the right spot.
You brought up a point. It's dependent on your mission and your capability. And routinely doing tests to 21,000 pounds is not going to be easy in most cases. But if you want to, for a period of time, reduce that within the mission that you're going to be accomplishing, you can do that. But then be careful if you take it above the point you test. So if you're doing your maintaining at, say, 5,000 pounds, then you would be planning on not operating above that.
Right, and that's, the point is to hammer home the idea that these aren't linear in many cases. So depending on the ship and the kind of operations that you run, you can't just have a set value that you stay in tolerance in necessarily, which never changes, I guess, is the point. Sometimes it'll be a much higher load versus a lower load through the same given load cell.
Yes, it's going to be mission dependent, time dependent if you want to reduce it from the maximum.
Yeah, so I think I'll reiterate that this calibration should not be your 1 1/4 test. this should be separate from that. So your Appendix B, 1 1/4 working load test should not be your calibration because, again, that's not the point you're interested in. You want your lowest safety factor that you're operating at to be your calibration point. And your low tension actually shouldn't be 0 either from a technical standpoint. But what should be your low value? Great question. So everyone can already tell I don't have an answer for that. I think it depends on your system and on your system spread. So you're going to want to look at, well, what is our lowest expected tension, right, that we're going to be interested at? What is the range we're actually interested in? So for some people, you know, like I said, it depends on the system. Now, saying your low weight should be 1,000 isn't useful on a system that only goes up to 2,000 because you're at a midpoint. You're probably going to want to be below that. I don't really have a rule of thumb for what your low tension calibration point should be, but I'll make up something, say 10% of your max. Yep.
Looks like we have a question or comment from John Zand online.
Yeah, I just wanted to confirm. So when you say that in Appendix A, you want a 3% tension calibration accuracy, that's for a single point? And it's not like your typical load cell, like you send it back to manufacturing, they'll calibrate it over, you know, a 20,000 pound load cell, they'll calibrate it every 1,000 pounds, and all of those points need to be within 3%. So what I'm gathering from what your response to Lance is, we pick a point that should be probably near the top end of our range of operating, and we need to stay within 3% on that single point.
Correct, because that's the only point we really care about from an Appendix A standpoint. If you have higher accuracy needs across the entire range, then adjust for that. But the only thing Appendix A cares about is that maximum tension that you see.
So that point, I guess, should be your factor of safety point then. So you care, all you care about then is whether you've exceeded that or not, and you're not caring if you've exceeded it by 20%. You're just like, okay, we exceeded it, we're done.
If you exceed it by 3%, you're within the margin of error.
Okay, yeah, thank you. All right,
The noise.
That's not how I had interpreted it before, so thank you for clarifying that it's just a single point that we need to make that 3%.
Could
and
save
I'd say,
some effort.
Yeah, I'd say we also find that we do only calibrate when we are doing our 125% test, but we can make that, because that's when we have the water bag, and we will make our calibration match our factor of safety 2.0 point at that time. And then it's pretty onerous to calibrate every 6 months. But we would, if we had an event, we would calibrate soon after and then do a post process correction.
Okay, yeah. Again, I say you want to be calibrating at the point of interest, not at the 125%. It's good that you're not doing that.
Great, thank you. I'm done.
Oh, is there another one?
When you keep in mind in your calibration, when you recalibrate, see how it is before you erase the data and put new calibration in there. So when you load it up to the point, and hopefully to the previous point if you can, see how it's doing. Is it still within the 3% or not? Rather than erasing and starting a new calibration.
All right, and then we have a question or comment from Don Kuchera from Miami.
Hey, Josh. Can you clarify some? Are we saying the LCI 90s are linear or not linear with the calibration? Because they have a high and a low point calibration.
So the load cell response is going to be nonlinear, but that is a linear calibration. Okay, because 90% of our ops are CTDs on a 12 bottle. So we usually put like 100 pounds for our low, and then we get a railroad wheel or 2 or 3 that's like maybe 2,000 pounds. So that's our low, and then our high. So that should be a good span. Is that correct? Yeah.
Okay, perfect.
Lance has another question.
Sorry, everyone.
Lance,
I guess
you can just call me.
Yeah, I know. I'm still not super clear, and I think I've narrowed the language to try and hammer this home. So here's a specific sort of framework here. Let's say I have 2 cruises scheduled on our calendar, and one is after the other. The first one is a 60-day cruise that is dredging at 5,000 meters. Expected tensions of, 18,000 pounds at the upper limit, let's say. And we run a calibration on our load cell for the high point of 18,000, or let's call it, 19.5. If the next cruise is a 60-day ROV cruise that has a maximum depth of, let's say, 1,000 meters, and our expected tension is never really going to go over, call it 10,000 pounds. Should I perform another calibration on that load cell with a high point of 10,000?
My question for you would be, do you actually care if you're below your safety factor point? How much does it matter that if you know your load cell's still accurate at that high point, and if you're not getting to that high point, how much do you care about that value that's in the midspan? If it matters a lot for the operation, then you probably should calibrate between trips. If you don't care because, let's just say you're only towing bongo nets off the 681 now, which I don't know why you would, and your loads are real low, you're not getting up to the yield point, which is what we're concerned about. So at our lower tensions, we're not concerned about the wire exceeding its yield point.
That is exactly my question, as a matter of fact. I don't care in the mid range is my point, and I'm trying to get maybe from Ted, if we're talking about maintaining 3% tolerance of some point. I'm going to bounce that question back to Ted.
Thank you, Lance. By the way, I know you had to get up early this morning. Basically, going back to your specific question, if you aren't exceeding your 6 months, you don't have to calibrate in between, provided your planned loads are less than would be applicable for the first test. So you don't have to. In terms of 3%, within that time frame, that 3% is based on your higher, in that case, the higher load. So you're shouldn't have any problems maintaining within tolerance limits during that period. Now, if you start going ahead past your 6 months of recalibration, that becomes a calibration requirement. Does that answer your question?
Yeah, I think so, because a part of my point is that if we're doing a cal for our set high, whether it be 2-point or multi-point, there's a pretty good chance that we're not within 3% in the middle. If we have a high point of 18 or 19.5, there's a pretty good chance that at 9,000, we are not going to be within 3% because that load cell just doesn't behave that way.
Your 3% is based on your load during the test. So your 3% would be 3% of the high level. And the other part is, in that case, you're so far below your high level, I don't think you have to worry about it.
So I think from an Appendix A standpoint, you don't have to worry about it.
That's perfect. That's the answer I was hoping for. Thank you.
Well, I'm so happy that I can give you that answer. Anything else? All right, any other questions along this matter? Don't ask me, ask Rick. All right, you can ask me, and I'll make sure it gets to the right people, maybe. Any questions on my program, feel free to talk to me, email, et cetera, send me a data file, and we can go from there. Any other questions? Yeah, always feel free to send me a message.
Okay, I think that concludes RVSS Appendix A and B Training 2024. So thanks everybody for coming.
If I could just say, a couple people have asked that they want to see the Hui dock. So we have a shuttle that leaves here and goes down to Dyer's Dock, which is right next to the Hui dock. Takes 10 minutes and leaves every 20 minutes from right down the entrance of Clark. So if you're interested, I'm certainly willing to show some people around. There's also a great restaurant bar. It's called Quahog at the lee side. They have a great view of the dock and a beautiful sunset. So I hope to see somebody there, and come on down.
Perfect, thank you. And a few other little logistical things. So I'll be gathering all the presentations as well as the documents that were sent out by Aaron Davis, and I'll be putting those in a file and getting that out to everybody. I'm also going to send out a survey to everyone that was here, both in person and online, to understand what worked, what didn't, what we can do better, how often we want to have this training, those kind of things. There's so much food left. Please take food. I hate wasting food. It hurts my stomach. Take it with you. Send it to, give it to your friends here at Hui, whatever. Yeah. Sure. How long is it going to be before there's a link? I'm not a very techie person at all, but Alice is, and so it'll probably be next week. Yeah, I just need some help doing it. The other thing, your name tags and your lanyards, you're welcome to take them, but if you don't want to, you can just put them on the back table there. And something that would help me out a lot is if you unhook them and so that the lanyards were different or separate from your name tag. But again, you can take them if you want. And then lastly, Brian, do you want to give your offer again?
Yeah, if you would like to just stop by and take a peek at what the East Coast Winch Pool looks like,
you're more than welcome. Just let me know. And you can easily just follow me. But the simple way is you go back out to the main road, take a right, and you'll see a sign about a quarter mile down on your right-hand side that says shipping and receiving, winch pool, et cetera, and take that right there. So out of here, take a right, quarter mile, take a right. Thanks.
Awesome. All right, thanks, folks. Thanks, Josh.
All right.
Oh, great.
Was it?
Yeah.
Okay.
I mean, I don't understand anything that you said, but that doesn't matter. Perfect. Yeah. Well, Wendy ran it but right now it's Alex. Yeah, she was like great. Yeah. We're doing it. Yeah. We're having it.
Yep, got this, that's back there, that's that, I took one plug, got my thing, got my mic.
Thank you, Josh.